Hi, I'm Chris, and welcome to another tutorial on using Adventure Creator in Unity. This is going to be a remake of the earlier 3D tutorial that I posted a few years ago, but it's been updated for the latest releases of both AC and Unity. AC, or Adventure Creator, can be downloaded from the Asset Store, and we're going to be using version 1.61.2, and this is going to be in Unity 2017.3. Now this tutorial is going to be more complex than the other ones. If you're just getting started with both Unity and Adventure Creator, I recommend the 2D tutorial, and the Unity Adventure tutorial is better suited for those getting started that have some Unity experience. So this is going to cover some slightly more advanced topics, so it's a good idea to go back and watch those other ones if you're completely fresh. But with that said, I'm going to import this package here, and when it's finished getting the assets, it's going to give us this installation box telling us that it wants to automatically add this menu input and these 3 layers. It can do all this automatically, which we can allow just by pressing OK. And once it's finished, it's then shown these up in the console. It's shown that it's created the inputs and the layers, and we're now ready to just test everything's working, test everything's been imported properly, and we can do that by running either of the 2 included demo games. And we can do this by going up to the top toolbar and finding the new Adventure Creator and choosing Getting Started, Load 2D Demo, Load 3D Demo. I'll choose Load 3D Demo. It'll ask us to open the scene, which we can do. And it's also opened up the AC Game Editor window here. Now this is the main editor window that we'll be working with. It's a very vertical window, so I'm going to dock it next to my inspector here. And if I close this, I can access it at any time by going to Adventure Creator, Editors, and then Game Editor. So we can just run the demo game. I'll just mute the audio, press play, and just check that everything's working just fine. And yeah, here we go with the intro playing. So now let's begin making our own game. If we have a look at the game editor up here, you can see we've got 8 tabs. We've got Scene, Settings, Actions, Variables, and so on. And each of these tabs refers to a different aspect of development. For example, the Inventory tab here controls what inventory items we're carrying. And all of these sub-windows are referred to as managers. So this is the Inventory Manager, and you can see we've got the Asset File field set to Demo Inventory Manager. So what we're going to do first is create our own set of manager asset files that we'll use to create our new game with. And we can do that by going to the top toolbar and choosing Adventure Creator, Getting Started, New Game Wizard. And this will allow us to quickly assign and configure the main settings that we can use to get up and running. So I'll choose Next, enter in a game name. I'll be very imaginative and type in My 3D Game. Choose Next. Our camera perspective is going to be 3D. And our movement method, the default is point and click, but here I'm going to choose direct. Next again. Our interface, how do we want to interact with hotspots? Now there's a big section in the manual on what all of these options are, but I'm going to go with choose hotspot then interaction. And that'll mean that we can have as many icons as we like for a hotspot. We have a lot of control over the types of things that the player can do. Next again, the GUI system. I'll leave this as the default AC. It can all be changed later, but this just helps us get up and running with a default set of menus. Finally, we'll confirm all of our choices. I'll click Finish, and it will then go and create these asset files for us. So it's complete. I can close this. These messages down here can be ignored. And you can see now in our Inventory Manager, we've got My 3D Game Inventory Manager, and the same for all of these manager asset file fields. And if I click on one, you can see we've got all of these asset files here in my project window, and these are in a managers folder, which is a subfolder of this new My 3D Game folder that has been created in my assets directory. We've also got a manager package file, and if we double click on that, then all of these become assigned automatically. So for example, if I change the scene manager to the demo one, and then I double click on it, it automatically goes back to My 3D Game. And that's useful when, for example, updating Adventure Creator, because if you update the full package, it will revert to the demo asset files. So you can just double click on this after updating to quickly revert back to your own game's managers. For this tutorial, we're going to be using some additional asset files that I've prepared on the Adventure Creator website. You can get these assets from the top toolbar. You go to Adventure Creator, Online Resources, and then Downloads. And that will take you to the Downloads page of the AC website. And if we scroll down here, we've got Tutorial Assets, Evil Lair, and Wharf. So you can click on this, download it, and then import it into Unity by going to Assets, Import Package, Custom Package, and then find the file. We'll then get this Unity Package dialog window. Everything is placed in this Tutorial Files folder, and in that we've got two subfolders. We've got Evil Lair and Wharf. We're not going to be using Wharf, so I'll uncheck that so we don't import it. And when it's finished, you'll see we've got this Evil Lair scene file within the subdirectory. Now if I open that, you'll see the set that we're going to be working in. So it's kind of a 60s spy movies villains lair kind of vibe. We've got a giant laser here on the table, a control panel, and over here is a lift or an elevator that the player is going to come through. Now, one point I want to make clear is that this was made with an older version of Unity, and so the laser gun here is actually using the legacy animation system. Whereas we're going to be working with the animator or the mechanism system. So what I'm going to do is I'm going to find the laser gun's model file inside set, and go into rig. I'll change the animation type to generic, apply that, go back to the laser gun, and you can see it's now been changed to an animator component. And that's just more appropriate for this version of Unity. We can also do the same thing to our player character. Inside Evil Lair, we've got Tin Pot, and if I select him, I'll also change him to generic, click apply, and I think the brain is already set to generic, so that's all fine. So taking a look at this scene file we have, we've got three lights, this laser gun, the lift, and the rest of the geometry is in this Evil Lair model file. And let's now convert it into one that Adventure Creator can understand and work with. And that's very simple. We'll just go to the AC Game Editor, click on the Scene tab, and then we'll have these two options to organize our scene objects, one with folders, one without folders. I'll choose with folders, and that just means we have a bunch of helper empty game objects that we can use to organize our hierarchy. So for example, I'll pick up these lights and drag them into the lights folder here. And I can collapse that. And as we add prefabs into our scene using this scene manager, it'll add them automatically into these folders. But this is all optional, and you can work without these scene folders if you prefer. I'll also select the lift, laser gun, and Evil Lair models, drag them into the set geometry folder. And if we have a look at what else we've got, you can see right in the middle here we've got this blue arrow, and if I select that, we get it highlighted in the hierarchy. This is our player start, and in fact you can see it listed here in the scene manager as the default player start, and this is the position and direction that the player is going to be facing when the scene begins. So I'm just going to move it for the moment in front of this lift here, and then rotate it so that he's it's facing just away from the lift because the player is going to start at these doors when we begin our scene. If I go to cameras and then find the main camera, we find that this camera is here in the floor. I'm going to pick it up and you can use the camera preview to see where it's facing. Just pick it up and turn it to the right so we can just have a good view of where the player is going to face. Now we'll be changing the position of the main camera properly using the camera system later, but for now we'll just have it facing where the player is going to begin. So this scene is going to feature direct control, and that means we're going to use the keyboard to move our player around in 3D space. We're not going to be pointing and clicking. And that means that the player will be bound by colliders in the scene. So the first collider we want to lay down, and bearing in mind that at the moment all we have are model files. These aren't any colliders or anything. So we're going to add colliders to our objects so that the player can't go through them. The main set we have here, the main room model, is this platform model here. And if I view its inspector, it doesn't have a collider, so we're going to add that now. I'll choose Add Component, and then type in Mesh Collider, and it'll automatically assign the mesh as platform. And that means that the walls and the floor now have a collider attached. Now we're going to be making a player later on, but just so that we can quickly test this, let's drop in the demo game's player character. And we can find him in Adventure Creator, Demo, Resources, and he's called Tin Pot. So I'll just drag him into the scene and then run it. And you can see when we run it, he's placed at the player start, and I can use the WASD or the cursor keys to move him around. He's also not able to go through any of the walls, but he is able to go through, say, this big laser table here. So let's fix that now. I'll do the same thing to the laser table here. I'll select it and add a new mesh collider. I'll do the same to laser button. Actually, I think with this I'll check convex. Same with laser table. Then over here I'll add the same thing. I'll do the same thing to the coffee table and the sofa. Actually, I think with sofa I'll leave convex unchecked. And finally, this bin over here. So now if I run the scene, we are able to walk around, but we can't go through the geometry. Now, since we're using direct control, we're not going to be relying on pathfinding during gameplay. So when we move around, it's not calculating the best path, it's just moving the character in the direction that we've chosen. But generally, we still want pathfinding to be possible because we might want the player to walk during a cutscene or have NPCs move around the scene, and they'll rely on pathfinding, and so we need to create a nav mesh as well. If we go to the AC Game Editor, underneath Scene Settings, we've got Pathfinding Method, and this is set by default to Mesh Collider, which means we can place down a mesh to dictate exactly where any character can pathfind. But I'm going to change this to Unity Navigation, and that'll mean it can rely on a pre-baked Unity nav mesh. And now what we can do is take these colliders we've just added, for example the platform, and change the static field to Navigation Static. If I go to Window Navigation to open up the Navigation tab, choose Bake, we then get our nav mesh according to the collider. So I'll do the same for all these other objects. Take the bin, mark it as Navigation Static, the same for the laser table, the laser button, coffee table, and the sofa. If I click bake again, they'll all be taken into account when baking this nav mesh. So again, this nav mesh is not going to be used by the player when we're walking around, but it will be used when we're pathfinding the player during cutscenes. Finally, let's save the scene. I'll delete the demo games player from the scene, and we can now create our own. We can find a model to make our player character out of inside tutorial files, evil layer, and then tinpot. And we have this el_tinpot fbx file. If I select him, you can see that he's the same character as used by the 3D demo, but he's got a few more animations that we're going to be making use of. Again, in his rig, I've changed his animation type to generic, so that when we drag him into the scene, he's got an animator component instead of an animation. Now, converting a model file into a player character that AC can make use of is basically just a case of adding the correct components and tagging him up as player. But there is an easy way to do all this. We can use the character wizard to add all the necessary components automatically. So with the model file placed in the scene, I'm going to go to Adventure Creator, Editors, and then Character Wizard. And much like the new game wizard, this is just a case of pressing next and filling in the fields that we get. So this is going to be a player as opposed to a non-player character. The game object that is going to form the basis is going to be this model, which I'll drag in here, and it has to be from the hierarchy. Next again, how is our animation going to be played? We're going to be using the mechanism or the animator system. Finally, we've finished it up, and you can see we've now got things like this player component, we've got an audio source, and we've got a rigid body and capsule collider. Now the size of this collider might not be perfect. In fact, we'll reduce it a little bit. But the correct components are now on, and we can just tweak them to suit. It's also been tagged as the player, which means that AC will recognize this as the player in our game. And if we run the scene, we'll be able to move our player around like this. Obviously, he's not animating yet, but we'll fix that in a moment. But what I want to do first is make sure that he can walk everywhere around the scene. So if I go to the Scene tab here and move over to the other side of the room, you'll see that we've got this raised platform, and it might be that we can't actually get up because the step is too high, in which case we might need to configure him a little bit more. This step has a collider in the form of the platform mesh collider. So let's see how he manages when he gets over there. I'll have the game window move down here so that we can see both at the same time. And then with the mouse inside the game window, I'll look up at the scene window and see him move over to the step. So you can see he has a little bit of trouble if he's going straight on. So we can either configure his rigid body and size of his collider and so on. We could also try adding in a sloped collider here to make the step a bit easier to get up. But I want to show another method, and that is to replace the rigid body and capsule collider with a character controller, which Adventure Creator can also make use of. So looking at his inspector, I'll remove the rigid body and the capsule collider, and then down at the bottom I'll click Add Component, and I'll add a new character controller. We'll need to configure this a little bit. The bottom of the character controller needs to be at his feet. So I'll raise the center Y value to 2 and maybe reduce the radius a little bit. Let's see how he gets on now. So he now finds it much easier to get up that step. Let's now play around with his movement speeds. So you can see under movement settings we have a walk speed scale and a run speed scale. And his walking around is a little bit fast for me. I think we'll turn this down to maybe 1.5 and see how that looks. That looks a bit better. And then when he runs, we'll have the run speed about double that. So I'll set that to 3. Now he can't run just yet because we haven't defined a run input. So let's just copy these component values, exit play mode, and paste them back in. And that's just because Unity doesn't save changes made in play mode. If we go to the AC game editor and find the settings tab, scrolling down we have a list of available inputs. And this is a list of inputs that we can make according to the various settings that we've made in our game. So we can find this run input, and that could be either a button or an axis. So if we go to Edit, Project Settings, and then Input to open our Unity Input Manager, we've got a list of our inputs here, and I'll increase the size by 1 to 20, and then name this new input Run, and I'll map the positive button to, say, left shift. And now if I hold that left shift down, he moves a lot faster. Let's now work on our main movement animation. So the model has animation states for idle, and then walk, and then run. So we're going to blend these together according to how quickly he's moving. If we go to his inspector, we can find that we've got a list of mechanism parameters. The first of which is this move speed float, mapped to, by default, just speed. Now this will take the value of his speed if we define it in his animator controller. We've got an animator component up at the top, so let's first create a controller for him. I'll go to Create Animator Controller somewhere in the project, and I'll call this Player Controller. If I double click on it, I'll be able to view it. So let's go to Parameters and then click plus and then Float, and I'll make a new float parameter named Speed. So because this shares the same name as the text here, this parameter will be mapped to the speed at all times. So we can create a new blend tree to blend between idle, walking, and running animations. So I'll make a new blend tree and call this maybe locomotion. Double click on it. So here we have a 1D blend type blend tree, and it's already mapped to the speed parameter. So I'll add 3 motion fields. The first one is going to be linked to his robot underscore idle animation. The next will be his robot underscore walk and run. So as this speed parameter changes, his animations will blend together. Now more of this can be found in Unity's own documentation. All we're doing at the moment is just using Unity's own animator workflow. Now when he's walking, this speed parameter is going to take the value of his walk speed scale, so 1.5. And by default, this is just the middle of the blend tree, it's 0.5 because we've got automate thresholds checked. So I'll uncheck that and set the run threshold to 3 and the walk to 1.5 because these are the values that the speed parameter is going to have when he's walking and running. I'll also assign this, this controller in the animator's controller component. And now when we run the scene, he's able to transition between those different animations depending on how quickly he's moving. We also get a few console errors relating to parameters that we haven't defined. So we've got this parameter jump does not exist, and that's because we've got a jump parameter listed here in our mechanism parameters. We're not going to be using jumping in this tutorial, so I'm going to delete that. And as for isTalking, this is a talk bool that basically is checked whenever the character is talking and unchecked when he's not. We have a talking animation in our model. Now this is a simple full body animation. If we wanted to, we could get quite complex and have like a head only animation and then map that to a different animator layer. But we'll keep things simple and just have a new state on our base layer. So first of all, I'll make a bool parameter named isTalking. And I'll drag the talk animation into the base layer, rename it talk, and we'll have a transition from the locomotion to talk and one back. And I'll have these without exit time, and the condition for playing talk will involve isTalking to be true, and I'll do the opposite for the return journey. I'll set isTalking to false, and then when he's talking, the isTalking parameter will be checked, and so this state will then run. Actually, I think we'll also make it so that he has to be stationary, so I'll have the condition speed is less than about 0.1, and then he'll play this only when he's not moving. And again, all of this is just using Unity's animator system, so go and have a look at the official documentation if you're just getting to grips with all of this. Now I'll add a few more custom animations and the ability to look around the scene at hotspots and so on with just his head, but we'll do that a bit later. For now, we'll make this the default player, and we can do that by first making a prefab out of him, by dragging his object into the project window. And then we'll go to the settings manager, and up at the top we have a character settings panel, a player field, and if I drag that prefab into the player field, this is then the default player, which means we can actually remove him from the scene and he'll be spawned in at runtime. Now, you may prefer to leave him in the scene and do without a default player, but this is an easy way of just creating scenes without having to worry about where your player is. Now that we have a player character we can move around the scene, let's add a more dynamic camera so that we can follow him a bit better. In the scene manager, we have a field up at the top for our default camera. So currently it's empty, which means we can click on create to make and assign one automatically. And we've got this navcam1 now in our game cameras folder. So let's move it to roughly where the main camera is now. And this camera is our default camera, which means it will be active when the scene begins. And if we then view its inspector, we've got quite a few movement and constraint options. Currently everything is locked, but we'll get more options as we unlock them each. So for example, we have X-axis movement, which when we unlock, we can control how the X-axis movement is controlled. So the best way to configure this is really just to play the game and experiment with different values. So the first thing I'm going to do after running the game is have the camera move in the same direction as the player is going now. And that is, looking at this gizmo here, that is the X-axis. So I'll uncheck X-axis movement lock, and then we get an affected by field. So it is affected by the target's X value at the moment, and that's fine. We'll have the influence be 1, which means when the target moves in one unit along the axis, so will the camera. But we'll increase the offset value so that it's a little bit closer to the player. And by the way, the target is the player because that is set down at the bottom. We can uncheck target as player if we wanted and make it any object we like. Now if we move over to the left here, the camera doesn't look at the player, it doesn't change its orientation. So I'll uncheck the lock option also in the spin rotation. And now we can choose how it's affected. This time I'll choose look at target because it's a bit easier to configure. We'll raise the target height offset a little bit, but basically it's just going to look directly at the player. The player is going to be in the center of the screen at all the time. I think as he gets over here, actually let's increase the offset a little bit more. But as he gets further away from the camera like this, we could have it so that the camera actually zooms in. So let's also uncheck the lock for field of view. And it says here we don't have any affected by field. The value will vary with the target's distance from the camera. So as he gets in, the camera will be more zoomed out. So let's give it a, let's start changing the offset value a bit. So minus 57, I've got it here. Oh, now he's actually getting really zoomed in. So let's add a constraint. And it does take a little bit of playing around, but basically we'll give it a maximum zoom of, say, about 30, and a minimum zoom of 30, maybe 20, and then a maximum zoom of 60. Now we could also play around with things like the y-axis movement, the z-axis. Although, if we now go over to the far edge of the scene here, you can see the camera is actually clipping through the wall. So this is what's happening. The player is coming here and the camera is going through. It's not aware that there is a wall here. So an easy way to get around that is just to add another constraint. So if we first of all move back to where the camera is not clipping, say about here, let's make a note of the x-axis position. That's about minus 17. And so I'll check constrain. I'll set the minimum to minus 17, and then it won't go beyond that value. And then I probably need to raise the maximum a bit as well, so it doesn't stop abruptly when we're moving back in this direction. Actually, I feel the depth of field probably changes a bit too quickly, so I'll lower the influence to 1 and raise the offset a little bit. So because Unity undoes any changes you make when you exit play mode, we're going to have to copy these component values again. So next to the game camera component, I'll choose the cog menu and then copy component. I'll exit play mode and then paste the component values back in. Looking at the values, I have tweaked the game camera movement options a little bit, so you can copy them here if you want to be exact. But I found that these just make it a bit easier to follow the player and see the rest of the objects around him. If we now move over to the left side of the scene, you'll see we've got this raised platform over here. We can move up and walk around, but the camera is now a bit far away, and it will be nice to have the camera actually cut to a new camera where we can see the player a bit better. We can create as many cameras as we like within the Scene Manager, and down at the bottom we have a list of scene prefabs. And underneath camera we have different camera types we can add. So let's just make a new game camera, which is the standard camera type for 3D games. And I'll rename this, say, navcam platform. And I'll position it so that it's looking at this separate area, like so. So we've got a bit of a better view. Maybe zoom it in a bit better, zoom it in a bit more. Again, you can configure all the lock options to make the motion nice, but for the purposes here, I'll say that's enough. Now we want the camera to cut to this new camera when we enter this area. And we're going to do that using a trigger. And a trigger is basically a volume that we can have actions run when an object comes into contact with it. We can create triggers in the same place in the scene manager. Underneath logic, we have a trigger type. So if I double click on that, it'll create a new trigger in the center of the scene. And the volume at the moment is just this red cube. So I'll name this platform camera trigger. And then I'll move this over to where this platform is. And have it cover the whole of this area by stretching it out like so. So if we view its inspector, we can see a list of properties that it has. It's set to react on enter, as in when the player enters it. It will only react during gameplay, and it will detect the player. So we could, if we wanted, have it detect any object. And then underneath we have this engine wait, and this is called an action, and the engine wait is the default action. So what we're going to do is we're going to change this to a more appropriate action by clicking on the engine, which is the actions category, and then we'll get a list of all the different category types. I'll change this to camera, and then we'll get a list of camera actions, and I'll choose switch. So camera switch will be the action that this runs. We'll then get a field for the new camera. So we're going to make this navcam platform. Now the transition time is set to 0, which means it will be a snap cut. So we can make things a bit smoother, maybe 1.5 seconds. And then we'll get more fields. So the move method is what kind of speed does it have. So we can change it to smooth. That's just the easiest way to get a slightly nicer transition. So I'll just test the scene and have him run over to the left here. And when we go up the platform, the camera will switch to this second camera we made. There's a couple of things wrong. First of all, we can't get back, but you might not have seen, but actually this menu button is disappearing each time he goes up. And that is because the action list here is blocking gameplay when it runs. And the menu that is appearing there is set to appear during gameplay only. So even though the action list runs very quickly, it's still blocking gameplay momentarily. And that's because the when running field is set to pause gameplay. So we can change this to run in background, and then that button will no longer flash off. Now for the return journey, we want the navcam1 to be the camera when we exit this trigger. So when we exit this same bounding volume. Now we could go and create another trigger of the same shape and maybe put it here. And so that when the player enters this, we cut to navcam1. But what we can also do is we can add another trigger component onto this same object. So I'll click Add Component and start to type in trigger, choose AC trigger, and then we get another component just like the one above. Again, I'll choose when running as run in background. The trigger is still going to detect the player, but this time I'm going to change the trigger type to on exit, and so this will run when the player leaves this volume. Our engine wait again will become a camera switch. The new camera will become navcam1. I'll give it a transition time of 1.5 seconds, and I'll make it smooth as well. So now when we move over to the side of the scene, we can go up the platform, we'll cut to the navcam platform, and when we leave, it'll cut back to navcam1. Now that we have a player character, let's lay down some hotspots so we can add some gameplay in the form of interactive objects. Hotspots are basically regions within our scene that we can click on to create interactions. So there are quite a few objects in our scene that we could make hotspots out of, but for the sake of this tutorial I'm going to begin at the moment with making a hotspot out of this laser gun and of these lift doors over here. Let's start with these lift doors. If I open up the set geometry and find the lift game object, we've got an animated component, and the if I find the model file, the lift model file has some animations that we want to be able to play. So before we do anything else, we're going to add an animated controller to the lift so that we can play back these animations as and when we need to. So in my 3D game, I'll create a new animated controller. I'll name it lift controller. And I'll drag it onto the animator's controller field. Let's double click on it to open it, and I'll drag the 3 animations we have. So let's actually see what these animations are. We've got a close animation, an open animation, and a shut animation, which is just one frame where the doors are closed. The doors are going to be closed to begin with, so let's make this lift doors shut animation the default one. So I'll right click and choose set as layer default state. Move this at the top, and then we're going to control playback according to an integer parameter. So I'll make a new int named state. Now there are a few ways you could do this, but this is the way I'm going to do it in this tutorial. But if you want to do it a different way, if you want to use a different kind of parameter, then that's fine. I'll then right click on any state and make a transition 3 times to each of these. And in each of these, I'll be checking the condition state equals. When it's equal to 0, we'll play doors shut. When it's equal to 1, we'll play open. And when it's equal to 2, it'll play close. I'll also, I think, reduce the transition duration for all of them as well. Oh, I also need to uncheck can transition to self so that it doesn't continually loop the first frame of anything. So if I drag the animator window down to the bottom and then have it open while I'm running the game, I can change the state value to 1, 2, and so on, just to test that this is all working. So now let's make this region a hotspot. And we can do that from the game editor, back in the scene manager, and then underneath logic we have a hotspot prefab. And if I click to create one, it will make a yellow cube, similar to the trigger, although yellow, that will define the volume in the scene that it has an effect. So I'll move it over to roughly where the doors are, or where they're going to be when they're shut. Now the shape of this is dictated by a box collider with isTrigger attached. But if we wanted to have something more complex, we could remove this trigger and replace it with any other collider type. Going through the hotspot component, we have a label if not name field. Actually, I'll rename the hotspot to hotspot:lift and then type in label if not name as lift doors. And then we have a few other fields that we'll ignore for the moment. Instead, we're going down to use interactions, and you'll see we have a plus icon here that we can use to create ones. So I'll create a new one, and then we get a cursor icon field in this new block that appears. And this is used to determine kind of the verb associated with this interaction. And we'll make our first interaction very simple. So we'll make a look at interaction, and we're going to have the player just turn to the hotspot and say something about it. So our player action is going to be turn to face, and then we have this interaction field that is currently unassigned. So I can click on create here to create and assign one, and this is a new object. And just like the trigger, this is an action list, and I can change the action to dialogue play speech, and I'll make the player just say something about it. So I'll check player line and then enter line text as maybe that's the way out of here. So I can click on it. It's a little bit hidden by the mouse cursor, but we then get this look at icon appear, and I can click on that to run the interaction. The interaction method that we're using at the moment is choose hotspot then interaction, and we can set that in the interface settings. And this mode basically means that we first click on a hotspot and then choose from a selection of icons the way that we want to interact with it. So we can have multiple use interactions on it. So let's make another. We'll make this one a use interaction. And this time our player action is going to be walk to marker, because we're going to make the player walk up to the lift and then the doors will open and we'll go through it. So we don't have a marker assigned, as this warning is giving us, and we're going to assign one up in this walk to marker field here. So again, I'll click create to make and assign one. And just like the player start, it's represented by this little arrow here. So if I put that on the ground, turn it in a little bit, because we can have the player face the same direction. So in the player action, I've got walk to marker, and I'll check face after moving. And then the interaction field, I'll create a new one. And this time I'm going to click on this icon here, and this opens up the ActionList editor. And this is useful if we want to have a series of actions as opposed to just one, and it's basically a node system to create our actions with. It's a lot easier than using the inspector. So before we start editing it properly, let's just have a think about what we're going to have happen. We're going to have the camera cut to maybe a new camera that's focused on the lift. The doors will open and the player will go through. The doors will shut again and we'll end the scene. So let's begin by making a new camera. Back in the scene manager, I'm going to create a simple camera, and this camera's inspector doesn't have very many controls, and it's mainly used for stationary cameras or custom cameras if you want to add your own camera script onto it. So I'll position it around here and name it maybe lift cam. We're also going to have the player walk through the lift doors, and we can set a destination for him by creating another marker inside the lift. So this can be done in the navigation tab. If I click on marker, I'll create a new marker here, and I'll call this marker inside lift. and I'll move it in to the middle of the little room there. So going back to our action list, and this is the lift door use action list. Our first action is going to be a camera switch, where the new camera is going to be lift cam. And I can drag out a little wire from these little circles underneath to create a new action very quickly. Next, we will make a object animate action. And this is going to be used to open the lift doors. So our animation engine is going to be Mechanim. Mechanim stands in for the animator system. The method is going to be change parameter value, because we're going to be changing the value of state. The animator is going to be our lift. The name of the parameter is going to be state, and we'll be changing an integer parameter to 1. I'll make another action. This time it's going to be a character move to point action. We're going to be moving the player, so I'll check is player, and the marker to reach is going to be marker inside lift. We'll wait until it's finished, and then we'll fade the doors out, and then we'll close the doors again. So another object animate that uses the Mechanim animation engine. It'll be controlling the lift animator and the state integer within it, and setting its value to 2. Let's also add a small delay here. So we'll have an engine wait of maybe 1 second, and then we'll add a camera fade action. The type is going to be fade out. It'll fade out over half a second, which is fine. I'll check wait until finish, and then we'll have one more action, and this is going to be an engine end game. So this will just end the scene. If we were making a full game and we wanted it to instead cut to a new scene that we'd made, we could instead make this a scene switch action. But we only have one scene in this tutorial, so I'll be making an engine end game. So if I now click on the door, we now have 2 options, use and look at. And if I click on use, it goes through the door, fades out, and it ends. Actually, I think I'll have a delay between we opening the doors. Where was it? This action here. I'll have a delay after we open the doors before the player goes through. And I also want the, at the moment, the player can actually walk through the doors even when they're shut, because there's no collider attached. Now the current collider only goes over the walls here of the platform. So what I'm going to do is I'm going to place down a collider that covers where the doors are going to be, and will disable it when the player is walking through it. So I'm going to add from the navigation tab in the scene manager a collision cube, and I'll call this lift collider. And this is represented by a blue cube this time. And I'll stretch it out similar to the way we did the hotspot. And just like with the hotspot, it's a box collider to begin with, but we can replace that with any collider that we like. But having this in the scene with a collision script attached means we can control it at runtime. So going back to our action list, before the player begins moving, we're going to turn off this collider. So this is going to be an object send message action. And this action can be used to invoke methods within any component. We're going to run the turn off method within this collision component. So I'm going to drag the lift collider into the object to effect field and then send the turn off message. And we'll turn it back on by running turn on. So I'll copy this action, and then once the player is finished moving, I'll paste in another one, wire it up, and then change this message to turn on. So I can't move through the doors, but I can if I choose the use action list. He walks through, we fade out, and the scene ends. Now the icons that appear, use and look at, are part of the default set, and these are set in the cursor manager. And the cursor manager has 3 interaction types: use, talk to, and look at, and we can use this interface to create or change any of these. One thing I do want to change is have it so that hotspot labels appear when we hover over each of these icons. So, for example, when we hover over look, this lift door label that appears above, we want that to say look at lift door, and similarly use lift door. We can do that just by checking prefix cursor labels underneath the hotspot cursor option. So look at lift door, use lift door. Let's move on and do the same thing for this laser here. Now this laser also has an animator, so I'll add a new controller, animator controller for the laser. I'll name it laser controller. Drag it into the controller field, double click on it, and I can access the various animations it has within the FBX file. So we have some animations for moving up, being turned off, on, and so on. So I'll drag all of these into the controller. I'll make on the default, move it up to the top, and again we'll make a new int parameter named state, and I'll transition to each of them from any state. On will run when state is equal to 0, move up when it's equal to 1, off when it's equal to 2, and turn off when it's equal to 3. And again, with each of these transitions, I'll uncheck can transition to self and clear the transition duration. So let's make a new hotspot for it now. Back in the scene manager, I'll click hotspot to make a new one. I'll name this hotspot laser. And I don't need to be too accurate about it, I suppose. I'll just rotate it and stretch it out. This looks about right. We can also view what we're doing from our game camera by pressing gizmos in the game window. I'll give it the label laser. Now we don't need a walk to marker because all I'm going to do is create one look at interaction, and we're going to have the player just turn to face. I'll auto create a new look at interaction, and then what we're going to have happen here is we'll have a little bit of animation, camera animation. We'll have the camera start about here and then maybe zoom in on the laser, and then the player can say something. So let's make another simple camera. And I'll put it down at the bottom here. maybe like so, and I'll call this laser cam 1. Then I'll make another one just by duplicating it, laser cam 2, and I'll reduce the field of view a little bit, maybe change the rotation. So selecting the laser look at action list editor, I'll change our first action to a camera switch, and this will cut to laser cam 1, and it'll be a snap cut, so it'll have a transition time of 0, and then it'll have another camera switch, this time to laser cam 2, but we'll have a transition time of maybe say 2 seconds. Actually, I'll make it a bit slower, maybe 5 seconds. I'm not going to check wait until finish because I want the player to say something before then. So I'll maybe have it wait maybe 1.5 seconds. I'll make another action, and this is going to be a dialogue play speech action. And then I'll check player line, in which the text is ominous. Now, there's a couple of ways we could now end the cutscene. What we want to do, obviously, is cut the camera back. So I'm going to make a camera and then switch action. And there's a convenient way of going back to the last gameplay camera just by checking this box here. So I don't have to be specific about which camera we're going to. So let's try this out. If I move over to this laser here and then look at it, it plays our little camera animation. Now that we've added a couple of hotspots, let's go back to our player and make a couple of tweaks so that we can get him to turn his head when we mouse over those hotspots. First of all, we'll go into the settings manager, and underneath hotspot settings, I'll check player turns head to active hotspot. But this will only work if the player is configured to be able to turn his head properly. So let's drag the player prefab back into the scene and view as inspector. So we have an option in our mechanism settings named IK head turning. And if our model file was a humanoid rig, then we could just check this, make sure that IK pass is enabled on the base layer, and be done. But this model file actually uses the generic rig, which means he's not able to do that. So instead what we're going to do is we're going to play different head animations of him looking left, right, up and down according to 2 float parameters. These animations are already part of the model file, so we have look down, look left, and so on. And we're going to play these using a 2D blend tree. We can define the names of 2 parameters to do this inside the player component's mechanism parameters panel. So we have head yaw float and head pitch float. So yaw is going to be basically the spin. I'll name this head yaw. And this will be -1 when he's looking left and +1 when he's looking right. And head pitch float, so this is his up and down, I'll name head pitch. And this will be +1 when he's looking up and -1 when he's looking down. And when he's not looking anywhere except forward, both of these will be 0. So next I'll add these parameters to our animator. Open up Player Controller, click on Parameters, and I'll add in a new float called head yaw, and another one called head pitch. Now we want the head to turn independently of his main walking and running animations, so I'll create a new layer, name this head turning, and in this new layer I'll click Create State from New Blend Tree, which I'll name Head Direction. I'll also click on the cog next to this layer, set the weight all the way up to 1, and set the blending to additive. So going into this blend tree, I'm going to change the blend type to 2D simple directional because we're going to be using two parameters, and those parameters are going to be head yaw and head pitch. So we have 4 looking animations, so I'm going to add fields for 4 motions. And I'll drag each of those animations into the fields. We now just need to set up the X and Y values for each of these directions. So positive X relates to the head yaw, or the spin left and right. Looking down, this will be 0. Positive Y, this is head pitch, so we want this to be -1. When he's looking left, the head yaw is going to be -1, and the head pitch will be 0. Looking right will be the opposite, +1 for the head yaw and 0 for the pitch. And looking up, we'll have a 0 yaw and a +1 pitch. And now when we run the scene and we mouse over any of our hotspots, the player will look in the appropriate direction. Let's now apply those changes back to the prefab and remove it from the scene. Our interface currently uses the default interface because that's what we opted for in the new game wizard. It's a little bit boring for this game. When we click on a hotspot, we get these small icons that appear underneath the cursor. So let's go and change some of these to make it a bit nicer. The interface can all be found in the menu manager, which is a list of all the menus that make it up. Now we can tweak all of these individually. For example, if I click on interaction, I can then change the appearance of this interaction menu that appears. But instead, we're going to make use of a template file that will give us a much nicer looking interface without doing much work. We can go to the downloads page of the Adventure Creator website, which again you can find at the top toolbar going to Adventure Creator Online Resources Downloads. And here we can scroll down to UI template Walking Dead style. And this will emulate the kind of interaction ring that you get in Telltale's Walking Dead series. This is another Unity package file, so once we've downloaded it, we can go to Assets, Import Package, and then Custom Package. We find the file and then import it. Now these files have been added to my Adventure Creator folder, and then inside Downloads, we have this Walking Dead template subfolder. And if I go into there, we have some folders for the actual asset files, but we also have this Walking Dead Manager package. And if I select that and view its inspector, we can see that it comes with a new Settings Manager, Cursor Manager, and Menu Manager. And if I assign managers, it will overwrite those particular manager types in our game editor. So in the Menu Manager, we now have our new Walking Dead Menu Manager. Same for the settings, but other ones like the actions and inventory are kept as they were. Now if we look at the list of menus that it comes with, we don't get a preview when we're looking in the game window. And that is because they all have a source field of Unity UI prefab. And that means that instead of using AC's own drawing system to render them, it instead uses canvas prefabs. So for example, if I, let's do the interaction menu, we've got this linked canvas field, and if I drag that into the scene, you can see we've now got this ring-based interaction menu being drawn using Unity's UI system. If you want to work with the standard Adventure Creator interface, we can switch this back to Adventure Creator, and then you'll be able to control its settings within the menu manager. If we go to the Settings Manager, a new Settings Manager was required because This changes the interface, some of the interface options to make sure that it all works. So we need to update some of these fields to the ones that we'd already made in our game. I'll change the save file name to my 3D game. Our player, again, I'll make EL_tinpot. And under hotspot settings, I'll check player turns head to active hotspot again. So let's now test our scene out again. And we're getting a few error messages here actually. We've got cannot display correct hotspot icon alpha on hotspot, laser and lift because it has no associated highlight object. So this interface relies on highlight objects, which is a property of the hotspot. So if I select the hotspot lift, you can see we have an object to highlight field. And this is used to add a highlighting effect when we mouse over hotspots. But it's also used by icons, which is what the Walking Dead interface uses. So what I'm going to do is I'm going to add this to our mesh and then assign it in here. So in my set geometry, I'll select the lift and add the component highlight. And I'll do the same to the laser gun. And then selecting the lift, I'll set the object to highlight as lift. And in the hotspot laser, I'll set the object to highlight to laser gun. Let's now try again. And we now get a much nicer interface for interacting with objects. And we can configure it all using Unity's UI system. But one thing that is missing now is the pause menu, which we normally access by pressing escape, but that's been now removed from our menu manager. And we can see those listed if I switch back to the My 3D Game menu manager. If I go to pause, we also have an options, save and load menus that we want to keep in our game even though we want to use the new interface. So what I'm going to do is I'm going to copy these onto the new menu. So I'm going to copy these into our new menu manager. And I can do that by going to either of these, clicking the cog on the right and choosing copy. I'll switch back to the new Walking Dead manager and paste that in. Do the same for the other three. There's options. Save. And load. And when we now run the scene, I can press escape and access that. These pause menus all rely on Adventure Creator for their source. So for consistency, we could change these back to Adventure Creator, but we can also set these pause menus to Unity UI. So I'll check each of them and set the source to Unity UI in prefab. So we have this giant laser slab in the middle of the scene. So let's add a victim to it so that we have someone we have to try to rescue. We have the perfect victim, and that's Brain. We can find him in tutorial files, evil layer, and then Brain. And we'll drag in the el_brain model file. And if he has a position of 0, 0, 0, then he's going to be already placed on the slab. Now his feet look a little bit strange, but this will all be corrected once we start playing animations. He also has an animator component already set up for us, but he's not going to be moving around, so I'm going to uncheck Apply Root Motion. So we're going to make this character an NPC, and just like with the player, we can use the character wizard to do that. So I'll go up to the top and choose Adventure Creator, Editors, and then Character Wizard. Going on to the next page, I'll say that this is going to be an NPC. His name is going to be Brain, and the game object is going to be this scene instance of the el_model. This is going to be animated with mechanim. So I'll choose next and then finish. And you can see he's then been given various components, main one being NPC. And it's here that we can configure his standard animations, if he was walking, how fast he'd move, and so on. It's actually added a few more components that we actually need. And notice also that because he's technically at the origin, although he already has a hotspot and a capsule collider, these are actually placed in the center of the scene. So this is going to be the area that we need to click on to interact with him. Now we could actually just pick up this collider and try to move it over to where he is, but it's going to be easier to just use a separate hotspot. So what I'm going to do is I'm going to remove the hotspot component, as well as the capsule collider and the rigid body, because he's not going to be moving around, he's not going to need one. And I can create a new hotspot back in our scene manager, scroll down, and while he's selected, I'm going to select hotspot, or actually rather, while his model is selected, and that's the brain child within this object, I'm going to check position over selected mesh, and I'll type in a prefab name of brain, or maybe hotspot :brain. I'll check add new, and you can see our hotspot's now been placed at the center of this model. Now the size isn't quite right, but I can go ahead, rescale it and rotate it to something a bit more appropriate. I'll drag the el_brain into my NPCs folder. And now let's have another look at the NPC component he has. So just like the player, he has some default mechanim parameters. He's not going to be moving around. Unfortunately, he's going to be trapped for the whole game. So we'll get rid of his speed parameter. And when he's going to be talking, he's going to be doing it using lip syncing. We're not going to be using a canned animation. So I'll remove the isTalking talkable. Going to his hotspot now, I'm going to set the label, if not name, to brain. Again, we'll assign an object to highlight. And this needs to be a renderer object for it to make a difference. So I'm going to find his brain model, add the component highlight, and then assign that in the object to highlight field. Let's also assign a walk to marker so that we have a place for the player to walk to when we click on him. I'll give it a Y position value of 0 so it's on the floor. And it's important to make sure that this is on the nav mesh. So I'm going to have the navigation window open while I'm positioning it. And I'm going to put it on this side of the table because we're going to have an animation play where he'll actually look in this direction. Looking at his animator now, you can see that we need to assign a controller. So in my 3D game, I'm going to go to Create Animator Controller again. I'll call this Brain Controller. I'll assign that into my controller field and double click on it so that we can start working on it. Now the brain, el_brain, actually has a set of 3 animations as part of his model file. Trapped idle is just his default idle state, just sort of sitting a bit gormless on the table here. We have look player, in which he turns his head to face kind of face over here, and we have dodge laser, in which we're going to have the laser come up a little bit too close for him, and he's going to try to get out of the way. So I'll drag these 3 animations into his base layer. And I'll make the idle animation the default one by right-clicking and choosing Set as Default State. And then we'll make a couple of parameters so that we can have it play the others. I'll create a bool parameter named is looking at player. And if I just move these apart a little bit, I'm going to have this determine whether or not we're playing this animation as opposed to this idle animation. So I'll right click and choose Make Transition from the idle to look player. I'll uncheck exit time and give it the condition is looking at player is true. And I'll do the opposite for look player to idle. So I'll uncheck has exit time, but make the condition is looking at player set to false. For the dodge laser, we're going to have this play with a trigger parameter. So I'm going to choose trigger as a new parameter, which I'll name dodge laser. And then I'll have it play from the any state. So I'll choose make transition, click on dodge laser, and then this will use the condition dodge laser, but I'll also uncheck can transition to self. And then when this is finished, we want him to return back to idle. So I'll right click again, make transition onto our idle animation. We are going to have an exit time, and so this is all fine. We can actually test these out if we run the game. So if I hover over brain, you'll see the interaction ring comes up. There's no icons at the moment because we haven't created any interactions, but we'll do that soon. And if I check the is looking at player parameter, you can see he turns his head. And if I trigger dodge laser, he'll try to get out of the way. Let's go and make an opening cutscene so that we can introduce the player to the laser, the NPC on the slab here, and give them an idea as to what they're going to have to do. So we've already got this lift over here that the player can enter. So our opening cutscene will feature the player standing at this green marker. The lift doors will open, and he'll come out, maybe say something, and then we'll begin gameplay. We'll be recycling the cameras that we've already made and the markers that we've made for the lift interaction. So the only new camera we're going to have to make is one that shows the NPC on this slab like so. So in our AC game editor, I'll go to Scene Manager and then create a new simple camera, which I'll name maybe Reveal Cam. And I'll move it up high above both the laser and the NPC so that we can see both and get an idea of what's going on. Maybe reduce the field of view a little bit. We can then begin work on our cutscene by again going to the Scene Manager, and then underneath the logic panel we'll choose cutscene. And I'll name this intro animation. If I then click on the node icon, I bring up the ActionList editor. I'll actually drag this to the right here so that we can also see the scene at the same time. So our first action is going to be to cut the camera to this camera here so that we can fade in and have the player coming out and we'll be able to see what's going on. So the first action is going to be a camera and then switch action, where the new camera is lift cam. We'll snap cut it so the transition time will be left as 0. And at the same time, we'll also teleport the player by choosing Object Teleport to affect the player, and the marker to teleport to will be marker inside lift. And I'll also check Copy Rotation so that he faces in the direction that this marker is facing. Then we'll make a camera fade action so that we can have a nice fade in. We'll leave the type as fade in, time to fade is fine, but maybe we'll wait until finish so that that all finishes before anything else. As I'm working, I can collapse the actions to make room for others, and then click on Auto Arrange to neatly arrange everything up to the top. Then let's animate the lift doors opening, so we'll add a Object Animate action. The doors are animated with Mechanim or the animator system rather than legacy, so I'll choose Mechanim. The animator is lift, and if we go back to our lift controller, to open the doors we need to set the state parameter to 1, so I'm going to affect the parameter state, and this is an integer, set as value 1. Now this action will run instantly, so we need to have an engine wait action to wait for the doors to open before the player comes through. So we'll add an engine wait of maybe half a second, and then we'll have the player walk out to the default player start. And we can do that with character move to point, check is player, and the marker to reach will be our player start. I'll check wait until finish. We collapse these again. Next, maybe another brief pause of half a second, and then we'll have the player turn his head. So we'll choose character, face object, where we affect the player, and the object we'll be facing is going to be the brain NPC. But instead of facing with his body, as in turning his whole root object, we'll face with his head so that he just turns his head. Now if we look at the NPC for a moment, the model and the animation is correctly playing on the slab, but the root object is actually placed at the origin. That's all the way over here, if I change the gizmo to center. So this is where the player is actually going to be looking, unless we override it with a neck bone for the NPC. So in the NPC component, we have a list of bone transforms and one for his neck bone. If I go into his hierarchy and expand his rig, hip, stomach, back, and then neck, I'll assign neck into his neck bone transform, and then the player will pick that up when we're told to look at the NPC. So he'll look around here instead. Back in our ActionList editor, we'll make the player say something. So we'll choose a dialogue play speech action. This will be a player line, and the line text will be, I'm gone for 5 minutes. Next, we'll cut the camera to this reveal cam we just made. So I'll make a camera switch action where we cut to reveal cam. Another brief pause of half a second, and we'll make the NPC say something now. So we'll choose another dialogue play speech in which the speaker this time is EL_brain. The line text will be, hey, little help. And we're now finished, so we can resume our gameplay camera, and we'll also stop the player locking his head towards brain. So we'll choose another character face object action. Again, this is going to be affecting the player and his head, but we'll choose stop looking so that he stops looking at brain. Otherwise, when we walk around the scene, he'll still be looking at him. We'll then have a camera switch action, and I'll check return to last gameplay so that it goes back to our default navcam 1. But I'll do it over time. I'll maybe set the transition time to say 2 with a move method of, well, I'll demonstrate the use of curved. So if I choose curved, I'll demonstrate the use of custom curve. And then we get a time curve field. And this basically allows us to really specify the motion of the camera over those 2 seconds. So a nice S-curve is fine. And if I leave wait until finish unchecked, then it means that the action list will actually end as soon as this is run for the first time. So we'll begin gameplay while this action is actually still taking effect. One other thing I forgot, and that's to actually close these lift doors again. So up in the top of the action list, I have this object animate that we made earlier. I'll choose copy from the cog menu on the right, and then maybe just before the player turns his head, I'll paste after, rewire it back up, and this time I'll set the state to, let me actually just check again, we want the doors to close. That will be a state of 2. One other thing I forgot also is that we have to disable the lift collider before the player can move through these doors. So if I go to navigation, collision cubes, lift collider, we've got to turn this off when we want the player to walk through it. So at the same time that we use the object animate to open up the lift doors, I'm going to insert another action that's going to be an object send message action. Actually, I'll make this a bit wider. And the object to effect is going to be lift collider. I'll be using the message turn off, wire it back up, and again I'll copy this and change it later on. So we have the other object animate here. I'll paste after again, wire it back up, and this time the message to send will be turn on. So if we run the scene, this cutscene isn't actually set to begin when the scene begins just yet, but we can run it manually by just going to the top and choosing run. So this cutscene seems to play okay. Let's now make it so that it runs automatically when the scene begins. In our scene manager, we have at the top a list of scene cutscenes, and these are special cutscenes. Now we can either click to auto-create one, or we can assign an existing cutscene. So let's assign intro animation, and then when we run the scene, it will play the intro automatically. But there is one problem with that, and that is that it's now going to run every single time we begin this scene. So let's imagine that in a larger game, we might have the player, after seeing this scene, go to another scene, and then return here. We don't want the player to then have to see this same intro animation every time. So what we're going to do is we're going to use a variable to determine whether or not we can play it. We can create variables in our variables manager, and if I click on the variables tab, we then have a choice of either global or local. And global variables are used whenever we want to access a variable in any scene, or more than one scene, and local is used when we're just working with one scene. So we can use local here, and then I'll click on create new local variable. This type will be a Boolean, and I'm going to name it scene opening cutscene. And its initial value is set to false, and that's fine. And what we're going to do is at the end of our intro animation, we're going to set the value to true. And then before we run this whole cutscene, we're going to check its value to work out whether or not we should play it. So back in the intro animation cutscene, I'll go down to the very bottom and create a new variable set action. The source is going to be local, and we can now set the value of scene opening cutscene to true. So now let's create another on-start cutscene that will run kind of before the intro animation. So back in the AC game editor, I'm now going to select the on-start cutscene field and press backspace so that it clears. It hasn't deleted the intro animation cutscene, but just stopped it from running when the scene begins. I'll now choose Create to create and assign a new default on-start cutscene. And if I open up the ActionList editor for that, it's just a standard engine wait. So what we're going to do here is choose whether or not to play intro animation based on the value of our new variable. So this is going to be a variable check action. Again, the source is local. So here we can check if the variable scene opening cutscene is equal to true. And if the condition is met, we don't want to play the cutscene again. So I'm going to change the socket to stop. But if the condition is not met, that means that the player hasn't yet seen the cutscene, in which case we're going to run it. So I'll change this to run cutscene, and the cutscene to run is going to be intro animation. And we can test this by running the scene. We have the opening cutscene run as normal, and if I go to the AC game editor, you can see that the value is now set to true. And so if I rerun the on-start manually, I can either do it from the inspector or by going to the ActionList editor and clicking run. It won't do anything. And that's because the variable is being checked and it's being told to stop. So we've now made this opening cutscene which plays when we begin the scene. But we also want to be able to skip it in case a player wants to be able to skip ahead to gameplay, or perhaps when we're testing, we don't want to have to sit through it every time. Now we could actually just go and manipulate the variable we created and set this scene opening cutscene to true, but then we'd have to change it back to false before we publish the game, so that's not really ideal. A better way is to just allow the cutscene to be skipped. And if we find the cutscene in Cutscenes and then Intro Animation, you can see that the property is skippable is already checked for us. And in order to skip any cutscene, we just need to press the End Cutscene Input button. And if we go to the Settings Manager, you can see again underneath Available Inputs, we've got an input button named End Cutscene. So we can define this in our Input Manager. I'll go up to Edit, Project Settings, and then Input. Increase the size by 1. I'll name this End Cutscene, capital E and C, and I'll map the positive button to Tab. And now if I press the Tab key when we play the intro, we can skip ahead. Now one thing you might have noticed when doing that was that the lift doors were not snapping instantly shut when we skip the cutscene. Now that closing animation might not be too much of a bother for this case, but if we were dealing with a larger animation or a series of animations that make up a more advanced opening cutscene, we wouldn't want any of that to show. So if I go into my intro animation action list, we can try to see what's going on that's causing that. You can see that we're animating the lift twice via the object animate action. We're first changing the state integer parameter to 1 to open it, and further down we are changing it to 2 to close it. But if we have a look at our lift controller, you can see that we have this lift doors shut animation, which is just a one-frame animation where the doors are completely closed. And that is run with the condition state is equal to 0. So what we can do is we can enforce the shutting of the doors when the cutscene ends. So I'll copy one of these object animate actions, go down to the bottom and click Paste After in the cog menu of the last action. And here I'm going to set the state to 0. And that will just ensure that the doors are completely closed when we finish the cutscene, regardless of what point we skip it. Poor Brain is sitting here on the slab here, so let's make it so that we can talk to him and maybe get him to tell us what to do in this little game. We already have a hotspot for Brain set up, and he already has a walk to marker defined, as well as a object to highlight. So we can go ahead and just start creating some use interactions. Let's add a couple of them by clicking the plus icon twice. We'll make the first one a look at and the second one a talk to interaction. For the look at, we'll make the player just turn to face and then run a speech action. So I'll click on create, open it up, and this will be a dialogue play speech action in which the player says, "I guess I'd better help him." And his talk to will have the player action set to walk to marker, which is going to be down here. And we'll check both cutscene while moving and face after moving. We can create a new interaction again, and this one's going to be a little bit more complex because we're going to cut the camera to about here so that we can get a nice perspective of both characters. In fact, let's do that as we go. So our first one is going to be a camera switch. So we'll make a new camera. This one I'll call Talk Cam. And I'll position it so that it's looking at the brain from kind of this side of it, because bearing in mind the player is going to be standing about here. So I'll get a nice over-the-shoulder perspective, looking up a bit, maybe zoomed in like that. So we'll have a camera switch action as our first action, switching to talk cam. I'm not going to worry about a transition time. And then we're going to have Brain turn his head. And that's going to involve manipulating his animator. So if we look at his animation controller, we want to play his look player animation, and that's done by setting the isLookingAtPlayer Boolean parameter to true. So I'll copy the name of this, go back into the ActionList editor, create a new action. This time we're going to be, actually it's going to be a character animate. We'll be animating el_brain. The method is going to be change parameter value. It's going to be isLookingAtPlayer. This is a Boolean, and the value is going to be true. Next, we'll have an engine wait, maybe about half a second, and then Brain will say something. So we'll have a dialogue play speech in which Brain says, "Hey, little help here." Next, we're going to give the player a chance to choose their response. So this is going to be a dialogue start conversation action. And this action at the moment is pretty bare. We just have an empty conversation field. So we need to create one before we get any more options. We can create a new conversation in the scene manager, and underneath logic we have conversation. So I'll create a new one. I'll name it BrainConv and add new. And then if I view its inspector, you can see that we can add as many dialogue options as we need. So we'll just keep this pretty simple. We'll only have a couple of options. The first will be, what should I do? The second one will be, don't go anywhere. Now we can configure the appearance of these options here in the inspector, but Actually, we're going to ignore these and just rely on the action list to control the way that the conversation runs. So in the dialog start conversation action, I'm going to assign our conversation as brainconv, and then I'll check override options. And what that means is that we can run all of the responses right here in the same action list. So what should I do relates to this socket. So I'll drag out a new action here, and this is going to have the player say that very line. So we'll have a dialog play speech in which the player says, "What should I do?" followed by another play speech in which brain says, "Use that panel to get me out of here." I'll collapse both of these and then reroute this second action back onto the dialog start conversation so that it reruns and shows those options again. For the don't go anywhere, this is going to be a choice that lets us exit the conversation. So again, we'll have a dialog play speech in which the player says, "Don't go anywhere," followed by brain replying, "Everyone's a comic." Now, leaving the last action with no follow-up action will just end the conversation, but we want to do a couple of other things before we do that. At the start of the action list, we cut the camera and we animated brain, so we're going to undo both of those. I'll select these and choose copy and paste them down at the bottom here, and then link them to the end of my speech. So when brain has finished speaking, we'll cut the camera back to navcam1 and we'll animate his is looking at player, this time setting the value to false. Let's test this out now. And if I hover over brain, I can look at him, we get a response, and then talk to him. And brain will now look over at us. We get these two choices. And we can then exit the conversation. Now, if we go back to talk to him, you'll see that brain says the same line before the conversation begins. And maybe this is a really complex puzzle, so we need to keep coming back to him to talk. We don't want him to keep repeating himself like this. So let's add a bit of variety to that opening bit of speech. Now that is the "Hey, little help here" speech action we have here. So what I'm going to do is I'm going to move this to a new cutscene first of all. So I'm going to select this and choose cut. And then in the scene manager, I'm going to create a new cutscene. And this is going to be called brainconv intro speech. Add new. And then I'll paste that action that we cut into it. Now we could do all of this within that last action list, but this just means that we can keep things a little less cluttered and makes it a bit easier to manage. So what we're going to have, instead of just one play speech, we're going to instead have a variable run sequence action to let us play a different speech action each time it's run. So our first action is going to be a variable run sequence, and here we get a choice of how many possible values it has. So let's say we have brain say 3 possible speech lines. So I'll set the number of possible values to 3, and you see we now get 3 output sockets. Now you can see here we have a selector for mapping this to a variable, but this is only necessary if we want the state of this sequence to be saved. If we don't, we can just uncheck Save Sequence Value and not have to worry about values or anything like that. You see the actions become a little offset, so I'll just collapse and reopen that just to set these back. And I'll check run on a loop. So basically what's going to happen is the first time that this action is run, it's going to use this first output socket here. So I'll connect that to our existing speech action. The next time it runs, it's going to run from this socket instead. So it's going to run this action, which I'll make another dialog place speech. This time Brain will say maybe found a way to help yet. And then again, the third time that this runs, it's going to run this third output socket. So we'll have another place speech in which Brain says, don't hurry or anything. And because we have run on a loop checked, that means that the fourth time that this runs, it's going to loop back to this first socket. So it's going to continually cycle between these three options. So this action list is now finished. And what we want to do is have our, if I can find it, we have our Brain talk to action list. And what we want to do is temporarily divert to that action list in between these two actions. So after the brief pause, but before the conversation begins. So what we're going to do is use an action list run action. The source is in the scene because we're running a scene-based cutscene. And the action list is going to be brain conv intro speech. And then we'll check wait until finish, and then connect this back onto our dialog start conversation. So this means we're going to run this separate cutscene, and when it's finished, carry on with this series of actions. So let's try it out now. So he says, hey, little help here, and we run it again, and he says, found a way to help yet. Now that we have a conversation with Brain, and he's saying a few lines, let's work on his facial animation. Facial animation generally consists of emotions and lip syncing, so his eyebrows and eyes and his mouth. AC has a number of options when it comes to this, and it can work with a fair few third-party assets as well as other tools, but for this tutorial we're just going to be working completely within AC. Now the model for Brain, if I select him and find his skinned mesh renderer, has a number of blend shapes, and each of these blend shapes changes his face in a different way. So we have a couple of expression ones, expression happy, which I can enable by setting all the way up to 100, and expression sad, and he has a number of phoneme or mouth shape blend shapes as well. But these blend shapes are interdependent on each other. For example, when we play the happy expression, we don't want the sad expression to play at the same time. The same with our phonemes, we only want one of these to be active at any one time. So we can use what's called a shapeable component to arrange these into different groups so that only one within each group is ever active. We can add the component shapeable to the skinned mesh renderer and use the inspector to define a shape group for expressions and a shape group for phonemes. Let's start with expressions, so I'll create a new group named expressions and then create a couple of shape keys within that. The first I'll call happy, and this will be mapped to the expression happy blend shape. The second I'll name sad and map it to expression sad. We'll come back to phonemes, but let's just look at expressions for now. Now there's a couple of ways we can manipulate this in our actions. First of all, let's find a place where we want him to change expression. So we have this brain conv intro speech cutscene, which is where Brain makes his little intro speech for the conversation. One way to manipulate the shapeable component is to add a new action and make that an object blend shape action. We can select a shapeable component, and then we'll have access to the group and the keys within that group that we can then manipulate over time. Now this is a good way for manually setting a key and having really fine control. But a much easier way is to rely on text tokens. So there are a number of text tokens that we can make use of. For example, I could insert in between hey and little, I could insert wait colon 0.5, and that would make the speech scrolling wait here for half a second. And speech scrolling, by the way, is set within the speech manager. Underneath subtitles, we have scroll speech text. But we can also use an expression token and use that to change which expression the character has. So I can insert at the start expression colon happy and put square brackets around that. And this will then tell him to use the happy expression. Now there is one more step necessary, and that is because the character doesn't understand any link between this shape group and what an expression is. So at the bottom of the characters inspector, we have underneath dialog settings a checkbox named use expressions. So I'll check that, and then we can add a couple of expressions. I'll name this happy and sad. Now normally you would use these to change a portrait texture, which is why we have these texture fields. And a portrait is a graphic that can appear as part of the character's subtitles label. So we can use this to change what 2D graphic appears on screen. But because we have a shapeable component, we can also check map to shapeable and then choose which shape group in that shapeable we're going to be relying on. And so when the expression happy token is called, it's then going to activate the happy shape key within this expression's shape group. So if I now run that line of dialogue, you can see his expression changes to match. I'll also add the sad expression somewhere in my brain talk to interaction. So perhaps when he says everyone's a comic, I'll put it, I'll type in expression colon sad, and then he'll change his face again. Let's now work on his lip syncing. Lip syncing within Adventure Creator comes down to two areas. We have the method of extracting phonemes and a method of using those phonemes to play an animation. Within the AC Game Editor's Speech Manager, near the bottom we have a panel for lip syncing. I'm going to set this to from speech text because it doesn't rely on any third-party applications. But if we wanted to use, for example, face effects or Pamela, then we could use those to generate phonemes instead. But from speech text just means that it will analyze the actual dialogue that we enter in the dialogue play speech action to generate an appropriate phoneme set. Then we can choose how we perform lip syncing. By default, this is just the portrait graphic, but I'm going to set it to portrait and game object, and that means that we can have the phonemes affect the blend shape. We also get a button to edit phonemes, which brings up the phonemes editor. And I can create a new frame, or as many frames as I like. And within each frame, what we do is we break up our phonemes into different frames. So for example, when he makes an R sound, we'll have that play as the first frame, or maybe an O sound, or a UH sound, an sound. And we separate these all with forward slashes. There is a much easier way to do this. I'll just click on Revert to Defaults. And what that will do is just assign 5 frames with a default set of mouth shapes. Now you can go and spend a fair bit of time doing this more accurately, but revert to defaults just gives you a quick set to quickly begin working with. So we now have 5 frames, and we're going to map these to our 5 blend shapes. Going back to the skinned mesh renderer, we have 5 phonemes. So what I'm going to do is I'm going to create a new shape group, this time called phonemes, and I'll have 5 keys within that. And it doesn't actually matter what the key labels are. In fact, I'll just leave them blank, but I'll map each one to a separate phoneme blend shape. And then going back to the characters inspector, we now have a new field that's appeared in the mechanism parameters panel, and that is the phoneme shape group. And I'll set this to phonemes, and that will cause the phoneme blend shapes to play in accordance with the current lip syncing frame. So as we talk, Brain is now able to open his mouth, and it looks a bit more realistic. A quick rundown of other options we could use. In the mechanism parameters, we also have a phoneme integer, which is a parameter we could define if we wanted to play things within the animator controller. Now this method relies on dynamic lip syncing, but if we wanted to play a pre-made canned animation, we could do so by entering in the name of these animations within our dialog play speech action. And we could also give complete control to another asset, for example, FaceFX or Rogo Digital's lip syncing asset. So Brain's animation on his face is a little bit more lively now. Obviously, being strapped to a table like this, he's probably not going to be too happy about it. So we're going to make him say a few lines of speech in the background while we're moving around the scene as the player. Now this is going to be running in the background, so we're not going to be blocking gameplay, but we're still going to be using a cutscene, because a cutscene is the easiest way to get actions running in our scene. So in our Scene tab, I'm going to create a new cutscene, and I'll name it Brain Background Speech. And this time I'm going to go to the inspector, and underneath Cutscene Properties, I'm going to change the When Running field from Pause Gameplay to Run in Background. And that means that it's not going to interfere with gameplay. So opening up the ActionList editor for it, I'm going to start with an engine wait of about 3 seconds, and then we're going to have him play different lines of dialogue at random. So our next action is going to be a variable, check random number. We're going to have him say one of 3 things, so we'll choose 3 possible values. And just like the variable run sequence action, we then get a different output socket for each possible value. So I'll drag out a new action for each of these, and each of these is going to be a dialogue play speech action, and Brain will be set to the speaker for all of them. I'll set the line text in the first one to maybe don't forget about me. Second one, maybe hello. And finally, I'm ready to be freed now. We're going to have these loop back onto this first action, but I want a bit more of a delay so that we don't bother the player too much. So I'm going to add another engine wait, this time setting the wait time to about 10 seconds, and I'll have each of these speech actions link up to it. Finally, I'll set the after running field to skip, and then the action to skip to is going to be our very first action, the engine wait. So if we follow up this blue line you can see that it goes back up to the very first action. If you want to actually hide this blue arrow just for this particular action, I can click on the cog here and choose Toggle Output Socket, and that just hides it from view, but we can still see the links to engine weight within the UI. I'll click Auto Arrange to line these up a bit neater, and then what we're going to do is have this run when we begin our game. So this will be back in our OnStart cutscene, and as before we have a variable check action that decides whether or not to run the intro animation cutscene. What we're going to do is we're going to amend this so that we can have the intro animation run followed by brain background speech. So I'll change run cutscene to stop so that we can access the output socket again, drag out a new action, and this will be an ActionList run, and we'll set the ActionList back to intro animation. And so the advantage of having a separate action to run this means that we can now press wait until finish, and I'll have another ActionList run that will run brain background speech. We can then make it so that when the intro animation has finished, it runs brain background speech, and we'll also make it so that brain background speech runs if we don't run the intro animation. You can test this out by running the scene again. If I skip the opening cutscene, wait a few seconds, and Brain starts speaking his background speech. There are a couple of problems though. We can start talking to Brain, and he'll actually start interfering with the conversation because the cutscene is still running. We'll also find that if we move over to the side of the room here, we're getting a bit far away from him, so we probably don't want to be able to hear him. Let's deal with the conversation first. We'll go to Brain Talk To, open up the action list, and then what we're going to do is pause the Brain background speech cutscene. I'll insert up at the top a new action. This is going to be an action list, pause or resume. The method is already set to pause, and we'll be pausing an in-scene action list, and the action list will be brain background speech. And then I'll rewire these so that after our first camera switch, it then runs this action list, pause or resume, before then carrying on with the character animate. We then want to resume this once we finish the conversation. So I'll copy it, go down to the very bottom where we have our last action in which Brain stops looking at the player. I'll paste in a copy of the action, wire it up, and I'll change the method to resume. I'm going to do the same thing to the trigger on the side of the room here. Our trigger can be found in Logic, Triggers, and then Platform Camera Trigger. And this will be going back a while, but we created two trigger components, one for when we enter and another one for when we exit. So let's work on when we enter. We're going to have the camera switch to NavCam platform, and we're also going to use a action list pause or resume to pause brain background speech. And similarly, when we exit the trigger, we're going to have another action list pause or resume in which we resume brain background speech. Let's work on this laser gun we have here and make it a little bit more interactive. Now we've already made a hotspot for it, but because it's high up, all we can really do at the moment is look at it. So instead we're going to turn our attention to this panel here which is used to control it. And because we've got quite a few buttons and joysticks here, what we're going to do is create a close-up so that we can really choose exactly how we want to work with it. I'm going to start by making a new hotspot that will begin the close-up. I'll go to the Scene Manager, go to Hotspot, and I'll make a new hotspot that I'll name Hotspot: Panel. I'll move it up, turn it, stretch it out so that it roughly covers the top of the panel. And I'm also going to make a new close-up camera. So I'll choose Simple Camera, and I'll name this maybe Panel Cam. I'll move it up and back a bit, turning it so that we can get a good look at it. That seems okay. And then going back to the hotspot, I'll create a new marker, a walk to marker. Move it out, give it a position in the y-axis of 0. And I'm going to check that this is on the nav mesh by going to the navigation tab. And yeah, I can see that it's within the blue boundary. Then we'll create a new use interaction. The cursor icon is going to be use. The interaction, we'll create a new one. And the player action will be walk to marker. And I'll check face after moving. Let's open up the interaction action list. And what we're first going to do is cut the camera using a camera switch to panel cam. And we're also going to disable this hotspot so that we can then interact with different hotspots that we'll make later. So I'll choose a hotspot, enable or disable. The hotspot to effect will be hotspot panel. The change to make is that we're going to disable it. And we're also going to limit the player's ability to move, because while we're in this close-up, we don't want the player to start moving around wherever they like. So I'm going to make a player constrain action, and you can see you can actually be very specific about in what way you want to limit the player. I'm going to disable movement in all 4 cardinal directions. Let's check our progress. I'll move over to the panel and use it. And you can now see that we've got this close-up, we can't move around, and we now want to be able to make these buttons and this joystick interactive. Again, in the scene manager, I'm going to make a new hotspot. This one is going to be hotspot joystick. I'll make it very small and place it around the joystick, roughly like so. I also need to give it a label, joystick. Actually, I forgot to do that for our hotspot panel, so I'll make this label panel. And then I will create a new use interaction. The player action can be left as nothing, but I'll create a new interaction action list. And I'm going to rename this to panel buttons use, because I'm going to create some new hotspots and I'm going to have them all linked to this same interaction, just for convenience sake. So I'll select the hotspot joystick and duplicate it, stretch it out, and then this will be the hotspot for all the buttons. Now I could actually make these all separate hotspots if I wanted, but in the interest of time I'm going to make them all one hotspot. I'll name the label buttons, and we're still linking to the panel buttons use interaction. Now, if we were being very specific, we could actually enable these hotspots at the same time that we disable the panel. But that's actually not necessary in this case, because both of these hotspots are within the boundary of this outer hotspot panel. And when we mouse over the hotspot using the cursor, only the hotspot closest to the camera will actually be interactive. So actually, these hotspots are actually only interactive when the panel has been disabled. We're also getting a few error messages down here, and it's referring to the hotspots that we've made need a highlight object. Those messages are showing because in our settings manager, underneath hotspot settings, we have display hotspot icons set to only when highlighting, which means it's going to show this icon here whenever our hotspot is selected. Now, it doesn't necessarily mean that we need to highlight our hotspot graphically, but we do need to associate our hotspots with a highlight component. So if I go back to the hotspot panel, you can see we've got an object to highlight field. I'm just going to add the component highlight onto the hotspot itself. And I can then assign it onto itself, like so. And to make sure that it doesn't have any visual effect, I'm also going to uncheck Auto Brighten Materials when enabled. And that'll just mean that it's not going to try affecting any renderers. I'm going to do the same thing for the joystick. And for the buttons hotspot. And when we run the game, those messages then disappear. But one more thing before we move on, you can see that when we mouse over, we can actually see the little center hotspot icon for the buttons hidden away there. And it's a bit hard to see here, but it's also showing for the joystick there. There's an easy way to get rid of that. We just go to Settings Manager, and inside Hotspot Settings, I'm going to check Hide Icons Behind Colliders. And that means that any colliders, including the main hotspot panel, are going to occlude the smaller hotspot icons. So now when we mouse over it, those little icons are gone until we get rid of the main hotspot. So let's now work on the action list that we trigger when we use either of these two hotspots. Because our player character doesn't yet know how to use the laser, what's going to happen is that he's going to inadvertently cause the laser to go a little bit too close for Brain, and Brain's going to have to get out the way. So first of all, we're going to animate the player using the panel. We have a few animations for cutscenes inside our tin pot model file. And if I find his inspector, you'll see we've got press button. We've also got some others like slam panel and so on that we're going to use later. So let's put these into our player's controller so that we can play them when we want. Inside my 3D game, I'll double click on Player Controller, and I'll drag these animations into it. So press button, slam panel, and take book, I'll drag into like so. And just for variety, I'm not going to use parameters to trigger these, I'm just going to call them by name directly. So I'll make these names a little bit simpler. I'll get rid of the robot, our robot. So we've got press button, slam panel, and take book. But I will add transitions from each of these back onto the main locomotion. And so for each of these transitions, we do want exit time to be checked. The exit time I'll set to 1 with no duration, so it'll snap back. And we don't need any conditions other than that. So the animation we want to play in this case is going to be press button. So I'll copy the name of it, and I'm going to go into our panel buttons use interaction action list. So this is going to be a character animate action. I'll be animating the player, and instead of changing a parameter value, I'm going to play custom. The name of the clip is going to be press button, and I can check wait until finish to have the action wait until this animation has finished playing. And that is one of the benefits of calling animations directly instead of using parameters. Next, we'll cut the camera. We'll use a camera switch, and I think we'll use one of the cameras we had in the intro, reveal cam. which allows us to see both the laser and brain at the same time. So we'll switch to reveal cam, and then we're going to animate with an object animate the laser. The laser gun uses an animator, so the animation engine for this action is going to be Mechanim. I'll assign laser gun as the animator, and if we open up laser controller, we're going to be affecting the move up animation. And if I select this transition, you can see that it runs when the state parameter, which is an integer, is equal to 1. So we're going to change the parameter value of state. This is going to be an integer, and we'll set the value to 1. We'll follow this up with an engine wait, because brain's a little bit slow. You might take a moment to realize what's going on. I'll give it maybe a quarter of a second. And then we'll animate brain with a character animate action. The character is going to be EL_brain. And let's have a look at his controller. I'll select him and choose brain controller. We're going to be wanting to play this dodge laser animation. And if we look at the transition we made for it, that's done by triggering the dodge laser trigger parameter. So we're going to be affecting the parameter dodge laser. The parameter type is trigger. Now, because we're using parameters here, we'll have to wait manually, but this is, I'd say, a second long. So I'll set the engine wait time to 1. And finally, we'll go back to our previous gameplay camera. So I use a camera switch and then check return to last gameplay. Let's test this out now. We now have a close-up when we click on the panel, and we can activate it to interact with some of the buttons on it. But currently there's no way to back out of it, which we're going to need to be able to do because the solution to the puzzle is actually going to be found elsewhere. We're going to create a new menu that will appear in the lower right corner, and this will appear when we're in a close-up, and when we click on it, we will go back to regular gameplay. We can manage all of our menus within the menu manager, and you can see we've got a list of the menus that make up the template we downloaded. We're going to create a new menu, and this will be called Close-Up. And the next field that appears underneath its name is the source property. And this refers to whether or not Adventure Creator renders it or Unity UI. Now, linking it with Unity UI takes a few extra steps, and we'll get to that in a moment. But first, we're going to leave it as Adventure Creator, because in a nutshell, Adventure Creator is a good way of prototyping your menus, because they can be made very quickly, and then they can be switched over to Unity UI for finer tweaking and making something a little bit more slick. So we'll leave it as Adventure Creator, and you can see in the game window this little yellow square, and that's the preview of our menu. And it's pretty small because we don't actually have anything in it. So we can address that by going down to the bottom. You'll see we have a list of close-up elements, and currently we don't have any. So we'll create a new element type button, and I'll click Add New. And you can see the menu in the middle has been updated with a new button element. I'm going to name this button Close Up Button, and the button text is going to be Exit Close-Up. I'll restyle it so that it's in keeping with the rest of the interface. I'll change the font to Creatinine Pro and set the text effect to Outline, maybe increasing the text size a little bit. Next, I'll come back up to the properties of the menu itself. We can set the position from centered to aligned, and then the alignment to lower right. Next, we'll have a look at the Appear Type field. Now, the Appear Type field determines under what conditions the menu normally appears. Currently, it's set to manual, which means we have full control over when it's turned on and turned off. But let's say that we, for example, open up the pause menu. We want to be able to automatically close this and reopen it again. So what I'm going to do is I'm going to set it to during gameplay. And we can see the effect that that has just by running the game. It's turned off during the cutscene, but when I skip it and re-enter gameplay, we've got this menu appearing. So what I'm going to do is I'm going to check Start Game Locked Off. And while the menu is locked, it's not going to appear even if its Appear Type condition is met. And what we're going to do is we're going to unlock the menu when we begin this close-up here. I think I'll also add a color to it so that we can understand when it's being highlighted. So underneath text color highlighted, I'm going to set it to, let's say, green. So we begin our close-up when we interact with the hotspot panel, and that's determined by this action list here. So I can create a new action, and this is going to be a menu change state action, and the change type is going to be unlock menu, and the menu to unlock is going to be the name that we typed in at the top of the close-up properties, and that is just close up. So when we now play the game, it doesn't appear, but it does turn on once I've clicked on the panel. We now want the button to actually have an effect. So when we click on it, we want the player to be able to walk around freely, we want the active camera to be navcam 1, and we want to re-enable the hotspot panel. Because if we have a look back at the use interaction list we made, we cut the camera, we turned off the hotspot, and we constrained the player. So we're going to do the opposite of all those things when we click on the close-up button. Inside the button's properties, we have a click type, and by default it's set to Run Action List. This is what we want, and we get this Action List to Run field, and I'll click on Create to automatically create and assign a new action list. An action list is just like a scene-based cutscene or interaction, except it lives as an asset file. And we don't get a node icon like we do in the hierarchy, but I can just double click on it to bring up the actions that control it. So I think what I'm going to do is actually open up my hotspot panel use action list. I'm going to right click and choose select all. I'll choose copy selected, and then in my action list asset file I'm going to right click and choose paste actions. Finally, I can delete this engine wait action so that the camera switch is the first one. I'll click auto arrange, and let's have a look at what the actions now look like. So one thing to be aware of is that our action fields now all have a recorded constant ID number. And this occurs whenever we reference a scene-based object. We have a number for our panel cam, and we have one for the hotspot panel. And these now also have little save icons next to them in the hierarchy. And that's to show that they've been given a constant ID component with an ID number that matches that in the action. Now this ID number is Adventure Creator's way of keeping track of scene-based objects within asset files, because I can save this scene and open up a new scene, and these scene object fields will no longer be filled in. But because we have a recorded constant ID, when we reopen the scene, they will be reassigned. So let's amend these fields to do the opposite of what they're doing now. Our camera switch action, instead of being panel cam, we're going to switch back to navcam 1, and you can see it's recorded a new constant ID for us automatically. It's also listed down in the console. Instead of disabling the hotspot panel, we're going to enable it. And instead of constraining the player by disabling movement, we're going to re-enable movement in all 4 directions. And finally, we're going to lock the close-up menu again. So I can click on the panel, our close-up button appears, and if I click on it, we'll go back to regular gameplay. I'll do a little bit of housekeeping before going any further. I'll right-click in the project folder and make a new folder called ActionLists, which I'll put my close-up on click inside, and maybe I'll make a controllers folder for the player, lift, laser and brain controllers. Now, I was talking a little bit earlier about menus being drawn with Adventure Creator or with Unity UI. So in keeping with the rest of the template, let's have this close-up menu be drawn with Unity UI. And again, that involves changing the source to Unity UI prefab. And if I change it, the preview will disappear because it's now relying on a Unity UI that doesn't exist. So let's go and create one now by going up to the top and choosing Game Object, UI, and then Button. And you can see we now have a Unity UI canvas with a button inside. I'll rename this canvas Close Up UI, and I can edit it if I open up the scene window, enable 2D mode, and then I can properly manipulate it. So I'll select the button and move it down into the lower corner like we had before. And if I expand that, I can get the text component. So again, I'll change the font to Creatine and Pro. Actually, we don't need an image component, so I'll remove that. The text will be the target graphic. Highlighting it will be green, and if I select the text again, we'll have it all white. Add the component outline, and I'll make the font size bigger. Now those few steps were to do with Unity UI. That wasn't anything Adventure Creator related. So if you want more information about that, then you can check Unity's own documentation. I'll rename the button BTN Close Up, just so we know what it refers to. And then what we need to do is we need to link it to Adventure Creator's menu manager. And because we've set it to Unity UI prefab, we're going to have to make this a prefab. So I'll go into my 3D game and then my UI subfolder, and I'll drag this canvas into the folder to make it a new prefab. You'll then see inside our menu's properties, we have a linked canvas field, which I'll assign as our close-up UI. And bearing in mind, this has to be the prefab and not the scene object. We have a rect transform boundary, but this only applies if we're dealing with, say, a mouse over UI, where it only appears when we're over a certain boundary. And further down, in the close-up button elements properties, we have a linked button field. So I'm going to assign that as the button close-up. And you can see, just like with the actions, it's created a new constant ID that we can refer to it by. One thing to note is that prefabs can only be expanded in the project window 2 levels deep. So if we had our button instead as a child object, like our text is, what we can do is we can have the button element selected in the scene window, drag this into our linked button field, and then just be sure to click Apply to send the changes that it makes back to the original prefab. So with these changes made, I'm going to remove both the UI and the event system, because the event system will be created by AC automatically. And we can run the game. And if I go over to use the panel one more time, you'll see that the menu turns on, but this time it's being rendered with Unity UI. We've seen how we can make a close-up and a button that then appears to exit the close-up. But since this is a direct controlled game, in that we're moving the player around with the keyboard, let's make it so that we can also exit the close-up by pressing a keyboard button. So what we effectively want to do is have an input button that triggers this button. Inside our AC game editor, I'll go to the menu manager, and then with the close-up menu selected and the close-up button element within that, we have a field named Alternative Input Button. And any button that we have in our input manager, we can enter in here, and then when that input is pressed, then this button will act as though it was clicked on. So let's go up to Edit, Project Settings, Input. This then brings up Unity's Input Manager. I'll create a new one by increasing the size by 1. And I'll rename this new input, say down, with a positive button of down and maybe an alternative of S to map the vertical axis. I can then enter the name of that input into the alternative input button field, and note that this is the name of the input in Unity's Input Manager, not the name of the button we're pressing. And then when we move over to the panel and activate the close-up, I can also press down or S to trigger that button and exit the close-up. There is another way to do this, and this is not really necessary given the alternative input button, but this is a handy feature to know about. I'll clear this alternative input field, and instead we'll make use of active inputs. And active inputs are a way of running action lists when we press a given button. We can manage our active inputs at the top by choosing Adventure Creator, Editors, and then Active Inputs Editor. And here we get a list of all the ones that we have. We don't have any, so I'll choose Create New Active Input. And we then get a series of fields. So our button is going to be down, and again this is what's defined in Unity's Input Manager. The input type is a button. It's enabled by default. Well, actually we don't want this checked because we're going to re-enable it when we are in the close-up. It's active when the game is in normal gameplay, and then we can define an action list that runs when it's triggered. Now we could click on Create to make a new action list, but we can reuse the close-up on-click action list that runs when we press the button. So all we now need to do is enable this input when the menu is turned on, and disable it again when the menu is turned off. So going back to our menu manager, you can see in the close-up menu's properties we have fields for an action list when it's turned on and an action list when it's turned off. I'll click on Create besides both of those to create two action lists, and I'll place both of those in my new action lists folder. Let's begin with the Turn On action list. So if I double click on it, I'll set the first action to Input, Toggle Active. I can then choose from a list of my active inputs. We're going to be amending the down, and we're going to be enabling it, so I'll check the new state checkbox. We'll do the opposite for the turn off action list, so double clicking that. I'll set the action to Input Toggle Active, and I'll leave the fields as they are, will be affecting the down input and disabling it. So again, I can move over to the panel, click on it, and I can press down or S and we'll exit the close-up. So we've made this panel interactive, but we don't yet know how to use it properly. And in order to turn off this giant laser, we're going to need some instructions. We're going to make an instruction manual in the form of an inventory item, and an inventory item is essentially any object that the player can pick up and use on other hotspots or other items. We can manage our inventory within the Inventory Manager, and with the Items sub-tab selected, I'm going to click Create New Item, and I'll name it Instruction Manual. We've got a texture in Set and then Textures, and I'll assign Book Icon inside the main graphic field. And we can test this out by checking Carry On Start to have it in the player's inventory when we begin the game. The Walking Dead template involves having items be displayed on the left and non-interactively, so we can't actually interact with them, and instead, to use items on hotspots, we include them as part of this interaction ring. I'm going to tweak this a little bit so that we can still hover over these items with the mouse and get a response from the player. We can do this by going to the Inventory menu and then choosing Inventory. And then inside its list of properties, we've got Ignore Cursor Clicks checked. I'll uncheck this, and if we were using Adventure Creator as the menu's source, this would be enough, but we'll need an extra step because this is a Unity UI prefab. I'll select the linked canvas down in the field beneath and find the WD Inventory UI prefab, and if I go to its inspector, we can see that it's got a canvas group component which is also interfering with cursor clicks. I'm going to check Interactable and Blocks Raycasts so that we can now click on the buttons inside it. If we run the scene again, I can hover over the mouse and get the instruction manual label at the bottom. I can also left click on it so that it becomes the cursor, but instead of having this, I'm going to change it so that we just get a line of dialogue from the player. We can do this by going back to the Inventory Manager, and we'll have a list of standard interactions. And the default interface is a 2-button system, so we have left click for Use and right click for Examine, and then we have 2 ActionList asset fields. I'll click on Create beside one of them, and before I do anything else, I'm going to move this to the My 3D Game folder and the ActionLists subfolder within that. I'm then going to assign it as the Examine action list as well, so that we can left and right click on it to get the same response. If I then double click on the ActionList asset file, I can get the ActionList editor, and I'm going to change this to a dialogue play speech action in which the player says, "I hope I don't have to read this." Testing again, we can then click on the manual and get a response from the player. But rather than have it in our inventory at the start, I'm going to uncheck Carry On Start, and then we'll have to pick it up within the scene. I'm going to place the book down here on this coffee table because nothing says good, light coffee table reading like a book on managing your own death laser. We can find a model for this book inside Tutorial Files, Evil Layer, and then Set, and then we have this instruction manual model file. I'll just drop it onto the coffee table like so, maybe turn it around, and then we're going to have the coffee table itself be another hotspot, because just like with the panel, I think we're going to be a bit too far zoomed out, so we're going to make this another close-up. To show an alternative way of creating hotspots, I'm going to do this manually. So I'll go to Create in the hierarchy window, choose Create Empty. I'll name this Hotspot : Coffee Table, and move this into my Hotspots scene folder. I'll then add the component hotspot as well as a collider. Because this is round, I'll just add a capsule collider, but it can really be any collider shape that you want. I'll check Is Trigger, raise the size a bit, and position it a bit more accurately around the coffee table. I'll also give this a label of coffee table, define a marker for it, which I'll put on the floor. I'll also go into the navigation tab just so that I can make sure that the marker is properly placed within the bounds of the nav mesh. Let's also make the coffee table itself glow when we mouse over it. So I'll find the mesh inside Set Geometry, Evil Layer, Coffee Table. I'll add the component Highlight and then assign that within the Hotspots Object to Highlight field. Let's create a new Use interaction. The default cursor icon as Use is fine. I'll set the player action to Walk to Marker and check Face after moving, and then create a Use interaction. This is going to be a close-up, so we're also going to need another camera. So back in my AC game editor, I'm going to go to the Scene Manager, and I'll create, this time I'll make a new game camera. I'll name this Table Cam, create new, and position it so that it's looking over the shoulder of the player as he goes to look at the coffee table. If I go to the camera's inspector, you can see that we've got all of these movement and rotation options. I'm going to leave these all locked, but I am going to check Follow Cursor, just to demonstrate that if we check this, we can have the camera just turn a little bit slightly as the cursor moves around the game window. So this coffee table hotspot is going to begin a new close-up, which is going to be very similar to the panel hotspot. So what I'm going to do is copy the actions from that panel's action list into the coffee table one, and then just change the fields a bit. So I'll find the interactions hotspot panel use. If I open up the actions here, I'll choose select all and then copy them. Go back to the coffee table use interaction, paste those in, and I'll delete the engine weight that we had by default. Clicking on auto arrange to arrange them a bit more neatly. The camera switch this time is going to cut to the table cam, and instead of disabling the hotspot panel, I'm going to disable the hotspot coffee table. But as before, we're also going to constrain the player and unlock the close-up menu. Let's now add a hotspot for the book. I'll move the instruction manual into the Set Geometry folder, and then with this selected, I'm going to go to the game editor, choose hotspot from the scene prefabs list, and then I'll get this position over selected mesh option. So if I check that and give it a name, maybe hotspot book, and add new, the hotspot will already be over the model for us. So I'll shrink it down a little bit, turn it, and again this is going to be within the coffee table hotspot, so we don't need to worry about it being clickable while the coffee table is active. Just as with the button hotspots, we don't need a walk to marker, but I will add the component highlight to it and just assign that as itself. I'll create a new use interaction, And again, I can leave the player action as do nothing, and then start working on the interaction itself. So what we're going to do is we're going to play an animation that we have of the player, which we can find in Tutorial Files, Evil Layer, Tin Pot, and then if I select the model file and go to his animation tab, you'll see we've got this take book animation. And what we're going to do is actually have the camera cut about half a second in and parent the book to his hand. Now it's a bit of a visual trick, but it'll look as though he's seamlessly picking up the book. We can play this take book animation again if we go back to his controller, player controller. You'll see that we can play it just by calling the take book clip by name. So returning to the book hotspots interaction. Now we're not going to animate the player in our first action for reasons we'll see in a moment. So I'm going to click Add New by right-clicking in an empty space and making my character animate action somewhere down here. I'll check Is Player, set the method to Play Custom and the clip as Take Book, and I'll also check Wait Until Finish. So what we're going to do is we're going to have this action run in parallel to another chain of actions. And that's so that we can have two chains of actions run simultaneously, and the action list will only finish when both chains are complete. We can do that by changing this engine wait to an action list run in parallel. And we could then set the number of outputs, which I'll change to 2. And we then get 2 output sockets to represent the 2 chains that we can run at the same time. So our first chain is going to be just this character animate, and I'll make a second chain beside it. We're going to wait for half a second, and then we're going to cut the camera using a camera switch action. We're going to now have to make a new camera to cut to, so I'll just duplicate the table cam and turn it so that it's facing where the player will be. Which I'll name Book Cam. And then assign that in the camera switch field. Next, we're going to have the player hold the book in his hand, and we can do that with a character hold object. We're going to be affecting the player. We'll be holding the object instruction manual, and he'll be holding it in his left hand. We now just need to configure our player so that he's aware of what his hand bones are. So I'll drag my player prefab into the scene, and you can see halfway down his inspector he has a bone transforms panel, a neck bone and 2 hand bones. If I expand his hierarchy, I can find his rig, base, leg, chest, arm L, forearm L, hand L, and he then has this hold.L, which is a separate bone that we can use to parent things to. So I'm going to assign that as his left hand. So bear in mind, it doesn't need to be his left hand specifically, just an object that the object will be parented to. I'll click Apply to update the prefab and remove him from the scene. Now we'll be having the instruction manual held by the player again later on, so instead of unparenting the object, I'm just going to hide it from view. So I'm going to add an object visibility action. We'll be affecting the instruction manual object and setting its visibility to invisible. We're also going to disable the instruction manual hotspot. So we'll have a hotspot enable or disable in which we affect the hotspot book and set the change to make to disable. And finally, we will add an inventory add or remove action to add the instruction manual to our inventory. So we have this coffee table hotspot, which if I use, activates this close-up. I can then use the book. Actually, I'll need to give the book a label, which we can then pick up and is now placed in our inventory. There was something else I forgot, and that is to cut the camera back. So I'll add a new action, which will be a camera switch and return to last gameplay. And I'll also go to the book hotspot and set the label as Mysterious Book. So we now have a couple of close-ups in our game. We have the close-up of the panel here and the close-up of the coffee table over here. And for both of these times, we have to run the same series of actions, but just slightly differently. And in both cases, we are cutting the camera, we're disabling a hotspot, we're constraining the player, and we're unlocking the close-up menu. Imagine if we were making a larger game with perhaps dozens of hotspots, we wouldn't want to have to create those same actions each time. Instead, what we can do is rely on ActionList parameters to let us recycle the same actions, but slightly change them each time. If you're familiar with function parameters in scripting, then it's a similar idea. Otherwise, don't worry, it'll all make sense as we go. We also have to deal with the fact that the close-up button currently only deals with this close-up here. So we're going to have to make it so that it works with any kind of close-up we have. But dealing with just beginning the close-up for now, we'll have a look at this hotspot panel use interaction, which has all of the actions that are involved when beginning a close-up. To make things easier, we're going to first move this to an ActionList asset, and this would also make it easier to have close-ups in other scenes as well. We can convert any scene-based action list to an asset file just by going up to the cog in the inspector and choosing Convert to ActionList Asset. It's then made an asset file out of our interaction, which I'll name generic enter close-up and place in my ActionList folder. So if I open up this asset file properly, you can see that it still references the scene objects, and again it's doing it by constant ID. So we're referring to the panel cam and the panel hotspot. So what we're going to do is make parameters to assign in each of these fields so that we can change them later. If I click on Show Properties, we then get the same box that appears at the top of the inspector, and I'm going to check Use Parameters. I'll click Create New Parameter twice to create two new parameters. And if we have a look at our actions, our first parameter is going to be to override the new camera field. So I'm going to name it camera to cut to. Going back to the actions, we also want to override the hotspot to effect. So the next parameter will be named hotspot to disable. And both of these are object fields, so we'll just leave these as game object. And then if we view the actions again, you can see that we've got this, this new field that has appeared above the new camera. But instead of it being an object field, it's instead a parameter drop-down. So we can assign camera to cut to as the new camera, and then the object field beneath it disappears. Let's do the same thing with the hotspot enable or disable action. I'll set the hotspot to effect as the hotspot to disable parameter. And now, whenever we want to begin a new close-up, we can just run this asset file and set the values of these parameters when we do so. So let's go back to this panel hotspot and open up the hotspot panel use interaction. Because we've already used these actions in our asset file, I can select them and delete them all. And then we'll replace this with a single ActionList run action. We're going to be running an asset file, so we can set the source to asset file, and then the ActionList asset is going to be generic enter closeup. It's detected that the asset has parameters, and we now get the option to set those parameter values here. So our camera to cut to is going to be panel cam, and the hotspot to disable is going to be hotspot panel. And this asset will now be run using those parameters. Let's do the same thing for our coffee table. I'll open up the interaction, delete all of the actions, and replace it with an ActionList run action that's going to run the asset file generic closeup. This time the camera to cut to will be table cam, and the hotspots to disable will be hotspot coffee table. You'll also notice that we're now assigning ID numbers for these objects, and that's fine. We'll just need to save the scene to make sure that those are saved. So let's now run the scene, and I can bring up the panel close up by using it, exit that, and then use the coffee table to bring up the second close-up. But we still have the problem of this exit close-up still being linked to the panel, which means when I click on it, it will switch to the nav cam that we'd set as part of that ActionList asset. So what we're going to do now is introduce parameters for the button ActionList as well. If we go back to the menu manager and find the close-up menu, we've got this close-up button on click ActionList. So let's open this up, and again I'm going to click show properties. We'll be using parameters, and I'll create two new game object parameters again. The first I'll name camera to cut to, and we're going to be re-enabling our hotspot, so I'll name the second hotspot to enable. Going back to the actions, in our camera switch, I'll set the new camera to the first parameter, and in the hotspot enable or disable action, I'll assign the hotspot to effect as the second parameter. But unlike the enter close-up ActionList, we're not triggering it with an ActionList run action, which means we're not able to set the parameter values all in one go. What we're going to do instead is go to the enter close-up ActionList and set the exit parameter values at the same time. So inside our show properties, I'm going to create a new parameter, and I'll name this camera to cut back to after. Maybe just cut to after. And the hotspot to disable is going to be the same hotspot that we'll enable later, so we don't need to make another one. Going back to the actions, I'll go down to the bottom and create a new ActionList set parameter action. The source will be asset file, and we'll be affecting the asset close-up button on click, and here we can define what this parameter value is. Normally we would just assign a new camera here, but because we're using parameters in this list as well, we can also map the exit parameters to the parameters defined here. So the exit asset's camera to cut to is going to be the same value as camera to cut to after, and I'll create another one by copying and pasting, and this time the hotspot to enable is going to be set as our hotspot to disable. I'll link these up, and because we've added a new parameter to this list, I'll go back to the hotspot panel use interaction, and the camera to cut to after will be navcam1. And if I go to the coffee table interaction, the camera to cut to after will be navcam platform. So I can access the panel close-up and click on exit close-up to re-enable the panel. Use the coffee table to bring up this close-up, and click on exit close-up to re-enable the coffee table hotspot. Finally, I'll just rename the close-up button on click to match the other one. I'll call it generic exit close-up. So we're now in the final stages of this puzzle, and we're going to complete it by using the book inventory item, the instruction manual, on these panel buttons here. But rather than reading it, what we're actually going to do is just have our little robot slam the book down and press all of them at once. We've got an animation for that. Inside his animation tab, we've got this slam panel animation that, as you can see, similar to the take book, is going to need to have the actual book mesh parented to his hand. So what we're going to do is create a cutscene specifically for putting the book in his hand. And the reason for that is that it's generally good practice to always put repeated actions into their own action list. So in the AC game editor, I'm going to create a new cutscene, and I'll call this book hold. And inside it, we're going to have a object visibility action, because if you remember, when we pick up the book, we actually hid the book. So in case we run this action afterwards, we're going to turn the book on. So I'll be affecting the instruction manual and setting its visibility to visible. And we'll also have a character hold object to place the manual in his left hand. I'll duplicate this and rename this copy book hide. Select this action list, and we'll change the visibility here to invisible, and instead of having a character hold object, I'm going to have an object set parent in which we affect the instruction manual and clear its parent. Let's merge these into our existing interactions. So for my hotspot book use interaction, I'm going to find the point where we have the character hold it, remove it, and instead I'm going to set the previous actions after running field to book hold. And at this point, after the character animate action, I'm going to delete the object visibility. Actually, I'll move all of these back up. And then at the very end, I'll set the after running to run cutscene. And the cutscene here is going to be book_hide. And what's convenient about putting those into a separate cutscene is that we can recycle those actions when we use the manual with the buttons. So with hotspot button selected, I'll go to the inspector and create a new inventory interaction just underneath my use one by clicking the plus. And this time, instead of defining a cursor, we can define an inventory item. So we only have one at the moment, so instruction manual is set. I'll create a new interaction for that. And so this first action is going to just have this book hold cutscene run. Now, if I were to do that within the after running field, this action chain would then end. So it would then move on to the other cutscene. What we want to do instead is have that cutscene run and then go back to the rest of this action list. So I'm going to have an action list run action in which we run the book hold cutscene. We'll then play the player's animation using a character animate. I'll check is player. The method will be again play custom, and this time the clip's name is slam panel. I don't mind this playing in full before we do anything else, so I can check wait until finish, followed by a camera switch so that we can see the effect. The new camera I think we'll set as reveal cam, because reveal cam allows us to see both brain and the laser. To animate the laser, let's find the laser gun's controller. We're going to play the turn off animation, which just needs the state integer to be set to 3. So next we'll have a object animate action. The animation engine will be Mechanim. The animator will be laser gun. The parameter to effect will be state. This is an integer or an int, and the value will now be 3. Let's wait a couple of seconds for that animation to play, and then we'll cut to maybe this camera, talk cam, so that we can get a good look at Brain's reaction. We'll have a camera switch, cutting to talk cam, and we'll have Brain speak using dialogue play speech, and he'll just say, "Phew, now I feel better." Now if we wanted to end the game here, we could do that with an engine end game action, but instead what we're going to do is pretend that this is part of a larger game. So we're going to create a variable that we can use to track the completion state of this puzzle. If we go back to our variables manager, and I'm going to leave the global tab selected because we're going to create a global variable, and this will mean that if we were making a larger game, we'd be able to check the state of this puzzle in other scenes, which might be useful for, say, other dialogue options. So I can click on Create New Global Variable, and I'm going to name this Turned Laser Off. Its initial value is false, which is right, and the type is going to be a Boolean. But after completing this puzzle, this is going to be set to true, and we can do that with a variable set action. The source is global, the variable is turned laser off, and the new value is going to be true. We'll then also cut the camera back to our last gameplay camera, and finally make it so that we can't run this interaction again. We can do that with a hotspot change interaction. The hotspot to change is going to be our hotspot buttons. The interaction to change is that we're going to change the inventory interaction and set its state to disabled. And that will just prevent the interaction icon from showing again. And after running all these actions, we then want to call the book hide cutscene once more, just to remove the book from the player's hand. So I'll set the last actions after running to book hide. And we can test this out a bit more quickly by just going to the inventory tab and checking carry on start for the instruction manual. So if we go to use the panel to bring up the close-up, and I hover over the buttons, you can see that we now have this icon representing the instruction manual as part of this interaction ring. Well, maybe you could spend a little bit more time tweaking it to making it look a bit nicer, but everything that we wanted to happen at least does. The inventory icon is now also removed from this interaction ring, and if we go to the variables manager, you can see that our variable has now been set to true. Let's also just tweak our previous interactions a little bit so that turning off the laser has an effect. So if we go to our panel buttons use interaction, and this is where we just try pressing buttons at random, let's change it so that it doesn't actually have any effect. So after the character animate, I'm going to detach that from the camera switch. Instead, have this go to a variable check action in which we check that the turned laser off is set to true. And if it is, we're instead going to have the player just say the line, I don't think that did anything. And of course, if the laser hasn't been turned off, we want it to run as it normally did. We can also do the same thing to Brain's conversation. So if we find the conversation action, we have the player ask, what should I do? And Brain's response at the moment is, use that panel to get me out of here. So let's just add another variable check action in between these two lines of dialogue. And if the laser has been turned off, we'll have another dialogue play speech in which Brain says, nothing, I'm fine now. We'll hook up the previous line and we'll have this new line go back to the conversation as well. This is getting a bit messy, so I'll check auto arrange, and it's a bit more neatly ordered now. So let's test this out again. I'll use the book on these buttons, and if I try to use the button again, then it won't have any effect. We can also exit the close-up, talk to Brain, and if we ask him what to do, then he'll say he's fine. With the player able to turn the laser off, we're going to call that puzzle completed so far as this tutorial goes, which means we're getting near the end of this. Before I do anything else, I'm just going to go back to the inventory manager and uncheck carry on start for our instruction manual. And then the only thing that remains is to get the save system working. Now I cover this in the other tutorial videos as well, but essentially Adventure Creator only saves what it knows that it absolutely has to by default. So for example, when we save the game, it will save maybe the player's position and rotation, it'll save what he's carrying, and it'll save the state of the variables. But so far as scene objects go, we need to be very specific about what we want saving, and that's done in the form of adding appropriate components. As an example, when we use the panel to get the close-up, we disable this panel hotspot. And because we can save during that close-up, we need to make sure that the enabled state of this hotspot is stored in save games. So with the hotspot panel selected, I'm going to go to my Add Component menu and choose Adventure Creator, Save System, and then we get a whole list of Remember components, and each one remembers a different aspect of your game object. So if I choose Remember Hotspot, this will then allow the state of the hotspot to be recorded in our save game files. And you can see that represented by the save icon beside it in the hierarchy. Similarly, we would want a remember animator on our laser gun. But rather than going through our scene and adding all these components manually, there is a much easier way to do it. We just need to go to the game editor, and at the top of the settings manager, I can just choose Auto Add Save Components to Game Objects. Actually, before I do that, I'm going to go to File, Build Settings, and just click Add Open Scenes to make sure that this is in my Scenes in Build. So then when I click on this Auto Add button, press OK to confirm what it's going to do, it will then go through the whole game and add all the components as necessary. So for example, if I go back to this laser gun, we can find the Remember Animator component attached. So that's it for this tutorial. I hope it was interesting and useful. If you want to check out more of the tutorials, you can find them on the Adventure Creator website, which you can access by going up to the top toolbar and choosing Adventure Creator, Online Resources, Tutorials.